I hope UFC fans get the reference. It's time.
Introducing first, flying from Singapore by way of New Jersey, USA, presenting the creator of Vue.js, Evan Yu!
Oh, man. Thanks, Luke. That was great. Okay, hello, everyone. I'm super excited to be back here. Oh, that's a lot of clap. And so I want to actually just get a quick idea. How many of you have been here before? Raise your hand. And first-timers? Wow, this is awesome. So it's a little bit crazy to think about. Last time I was standing on this stage was 3 years ago, right? Literally 3 years ago. So super happy to be back, super happy to see everything going back to normal. And it's also a little bit crazy to think about last time I was here, these things didn't even exist or wasn't released yet. So Vue 3 was not stable. Vite did not even exist. Volar didn't even exist. Pinia, Vue.use, Vite, Vite-Press, Histoire, a lot of these new exciting things that's happening in the ecosystem didn't even exist. So the 3 years, we are seeing a lot of, we essentially created a whole new ecosystem around Vite, and along with that, we have all these new exciting things built on top of it, not just within the Vue ecosystem, but like even connecting all the other frameworks as well. So a lot of things happened. But now let's get back to the focus to Vue itself. So a quick recap for last year. So February 7th last year, so exactly around 1 year ago, Vue 3 finally became the new default version. So right now, we're pretty much 1 year in with the default switch, where Vue 3 is now the default version. So the adoption is looking great, because essentially over the course of 2022, we're seeing Vue 3 usage essentially tripled over the course of time. I think it's important to note a lot of the legacy projects probably stay on Vue 2, so vast majority of these adoption are actually from new projects that's starting on Vue 3. So in the past year, we invested a significant amount of energy into just making the overall IDE and TypeScript support around Vue 3 more solid. So Volar 1.0 was a really major milestone for us because it essentially resolved a lot of the long-standing issues around IDE TypeScript support and also command-line TypeScript integration for Vue single-file components with greatly improved performance. So Vue.tsc, which is the command-line utility that allows you to type check normal TypeScript files alongside with Vue components, now also supports watch mode and supports emitting type declarations for your single-file Vue components. So this essentially brings up the TS experience for Vue single-file components to the same line with normal TS files. So great shout out to the work by Johnson, who isn't here, but if you see this, Johnson, you did a great job. Thank you. So Vue 3 ecosystem maturing. Nuxt 3, we saw tons of exciting updates about Nuxt. Once it got to stable, the team just started cranking out new exciting features. And some of the most important pieces in the ecosystem where people rely on, in particular UI frameworks like Vuetify, Quasar. We have also Vue 3 new options like Naive UI, Prime Vue, and not to mention Vue.use, which is essentially your go-to solution if you're looking for something that you don't know how to do yourself. Just check Vue.use. It probably has a solution for you. So we also shipped Vue 2.7, brought built-in composition API support back to Vue 2 with script setup, CSS vbind. So this aligns the base DX. If you are using composition API, now even both on Vue 2 and Vue 3, you can get pretty much the same experience. So this is also the long-term goal for us to bridge the gap and just bring the two versions closer. So even if you have to stay on Vue 2, you won't be missing out too much for the time being. So looking ahead for 2023, so we're still in this period of transitioning from Vue 2 to Vue 3, right? A lot of users, especially big projects, stay on Vue 2 or considering the option to migrate to Vue 3. So stability is still key. We believe that script setup and composition API is in a pretty good place. Options API is here to stay. So we don't want to make drastic changes that would force you to consider, oh, should we rewrite our code base or anything like that? So this is a pretty important consideration for us. But at the same time, we do want to start doing smaller and more frequent minor releases. So in the past a year or two, because I was investing a lot of time into Vite and other related ecosystems, so Vue 3 itself, we intentionally wanted to just leave it stable, let people slowly get into it. But now that I believe we're in a pretty good spot for me to move the focus back to Vue core and start shipping more features in Vue 3 itself. So in order to facilitate this plan, we recently did some core infrastructure, Vue core infrastructure improvements in the Vue 3 repo itself. So 3 important things we did. The first is introducing ecosystem CI. And then we essentially completely rethought about the test setup, the build setup, just to make everything faster, make it easier for contributors to get a better development experience. And for myself, obviously, because I have to work on it day to day. So ecosystem CI is adapted from Vite's excellent ecosystem CI implementation by Dominic, who was here at the Vite panel. So ecosystem CI allows us to essentially have a place where we can pull in integration tests from ecosystem projects that has Vue core as the dependency. For example, you can pull in Nuxt or VitePress or the Vite plugin Vue. All of these projects, we pull them in and run their test suites using the latest commit or arbitrary commit that we choose from the Vue core repo. So the CI process will automatically allow us to say specify a commit or a release tag or anything. It'll pull that commit from the Vue core repo, build it from scratch, and use a local mock npm registry to publish them to simulate the actual installation process as much as possible from these downstream projects. So these downstream projects will actually install Vue from the mock registry, npm registry, and then run their test suites. So we'll start doing this probably on a fixed schedule, and also anytime we do releases, before the release, we'll run it, make sure we don't accidentally break anything. In fact, this setup has already helped us catch quite a few issues in the new build setup itself. So I think it was the right decision to do this before we started doing big refactors on the whole build setup. So faster test setup. We migrated the Vue core repo from Jest to Vitest. So going full circle, we're finally adopting Vitest itself at the root of the whole ecosystem. We migrated 175 test files, including 2,600 test cases. And I did that in one day. So I mentioned yesterday I wrote a simple script to convert some of the common things. It's mostly just changing the API being called from Jest to Vitest itself. And other than that, not much has changed. When we disable threads, the unit tests on CI went from 1 minute 38 seconds down to 32 seconds, and the local test feedback speed also increased significantly. We also implemented a faster build setup. So before I go into the details, a comparison. Previously, Vue core's setup wasn't really optimal, right? There had always been this room for improvement I've always wanted to do, but it was kind of risky without the ecosystem CI in place because it involves potential different outputs, different type generation. So after ecosystem CI was in place, I went ahead and did it. So now the build plus type check plus generating all the type declarations for all Vue internal packages, before it took over 3 minutes, close to 4 minutes. Now it's 18.8 seconds. So that's a 12 times speed improvement. So the details of what we did was we first moved from Rollup plugin TypeScript to Rollup plugin ES build. So now this change was challenging previously. I didn't do it in the past because, first of all, this removes type checking from the rollup build, which is in fact good because we can do type checking separately using just vanilla TSC. Now, plugin ES build has an issue because ES build when it transforms these files in isolation, we're not using ES build itself to bundle view because rollup still generates more efficient tree shaking, smaller bundles. But we use ES build for its speed. And when ES build is transpiling files in isolation, it cannot handle const enums. So that was the blocker which prevented us from doing this in the past. So this time, I actually sat down and wrote a custom rollup plugin. Just do the custom. Essentially, this plugin does constant enum pre-processing by itself. So it just converts all the constant enum usage to what TypeScript would normally spit out, and then let ES build to pick up the rest. So this is the major speed up that we saw. And we also moved from API extractor to rollup plugin DTS with a custom rollup plugin for internal API trimming. So essentially doing the same thing, but a lot faster. So these two combined give us a 12x speed improvement for building Vue itself. This is also so this step was in fact kind of interlocked with ecosystem CI because previously the build process was so slow that it caused ecosystem CI to occasionally time out. So after we implement this, now ecosystem CI just runs very smoothly. OK, so now let's get into a really rough roadmap. This is going to be very high level. For Q1, the major focus will be quality of life improvements and bug fixing, because we do have a pretty long backlog of bugs that we do intend to address. So Q1 will be essentially a focus period where we just try to get the numbers down and ship some of the long-standing. There were a lot of PRs that were already ready. So the plan for 3.3 is being adjusted because the reason 3.3 has dragged on for so long was that we were hoping that we could land reactivity transform and suspense in 3.3. But after thinking hard about it, we decided that it is best to decouple the minor release cadence from these two experimental features for now and focus on other low-hanging fruits that we can ship earlier and faster. So some of the examples are external type support in script set of macros. So when you use define props, using the type signature, currently, if you that type signature includes types imported from an external file, it just cannot analyze it. But we intend to address that. Safe teleport, which Yum has implemented as an external package. We want to make that as the new default. And we have a bunch of TypeScript improvement PRs, which we did not merge, mostly because of worrying about the compatibility of newer TypeScript versions. So this is something we do want to address in 3.3 as well. And as you probably, some of you probably already are aware of, we are dropping reactivity transform. So reactivity transform was this experimental feature or RFC that's been going on for quite a while. We went through quite a few different iterations of it, hoping that we could further reduce the verbosity of having to use .value and improve the DX. But after going through this, shipping it, and actually testing it in real code basis, we found that the DX improvement was rather limited, mostly because the friction when you use reactivity transform, when you go past the values in and out of functions or across component boundaries, you need to pass the reactive variable into a function that's imported from an external file, right? At all these boundaries, you have to still think about the conversion between a reactive variable and a ref. So so while it reduced the mental overhead in one area and introduced new mental overhead in another place, it is also less obvious after you use reactivity transform, it also becomes less obvious on whether a variable is actually reactive because it looks like a normal variable assignment. So when this is okay, kind of okay inside the component itself, but because reactivity transform is designed to be usable outside of components as well, and we discovered that when it's applied in normal JSTS files, it just makes the code actually a little bit harder to understand because the distinction between reactive and non-reactive variables is now lost. So, and finally, obviously, there is the risk of fragmentation because it's yet another way for you to write your components. And so considering overall these, combine all these considerations together, and with discussion with the team, so the team has essentially unanimously agreed to drop the reactivity transform. So it was marked as an experimental feature, so it does mean, so if you have been using it in production, it won't suddenly break. So in 3.3, we will start receiving a new warning telling you you are using a feature, experimental feature that has been deprecated, and you should start migrating away from it, or start using a new package which we will provide. So likely in Vue macros, which I believe Kevin has already implemented support for in Vue macros. So you can start migrating to use Vue macros for reactivity transform if you do intend using it, but it will no longer be a Vue core feature. And in 3.4, it will be officially removed from Vue core, so you will have to start use external packages if you still intend to use it. So there's something that's useful that came out of the whole proposal, because we believe the reactive props destructure will still be quite useful. In that previously, if you want to define props with defaults, we have to use this quite awkward with defaults helper. And you would have to remember, do not destructure here, because otherwise you will lose reactivity for the props that are coming from parents. So you will always have to remember to do props foo previously. So with reactive props destructure, you can use the native JavaScript syntax. When you destructure, this destructure value will automatically be kept reactive. So you no longer need to worry about losing reactivity when destructuring props. And also, you can use the native default syntax for declaring default values. So you no longer need this awkward with defaults helper. And it just looks much cleaner. And also, when you are not using TypeScript, without the type signature, we can actually infer the props that you intend to declare directly from here. So you don't even need runtime declarations when you're not using types, unless you want to do custom validators, that is. OK, so Q2, we intend to bring along a bunch of server-side rendering-related improvements. So this will likely be done in coordination with the Nuxt team. We want to finalize the suspense API lifted out of experimental. We intend to introduce lazy hydration at async component boundaries so that you can have custom strategies on how an async component tree should be hydrated. For example, if you have a long page where many components are actually below the fold, you can say delay the hydration until it scrolls into view, or delay the hydration until the user mouse hovers over it with the intention to interaction. So we will we will post an RFC with the detailed design before we implement it. And then we're also exploring the ability to declare a piece of your template to be server-side rendering only. So an example of that is, for example, is that you are fetching some data from your database, and you're using that data in your templates. So this piece of data is static at the front, in the front end. So on the front end, you know that they will never change. But we're still using a dynamic binding in our templates because it needs to be used during server-side rendering. So we want to give you a way to declare that although this template contains dynamic binding, it doesn't actually change on the client. So when we're doing the client build, we can ignore all these dynamic bindings and somehow compile them differently so that on the client, it's just a placeholder. It'll just pick up the markup that's already there and don't need to actually do any work during hydration. We also intend to provide better hydration mismatch warnings, so it makes it easier to debug when you run into it in production. So these are not all, and to be clear, a lot of these are kind of the tentative plans. A lot of the details will be finalized when we actually start working with the RFCs. So the discussion process will be open, so make sure to stay tuned and get involved. So Q3 and Q4 will be focused on Vapor mode. So I've mentioned this a few times in past talks, but the gist of the idea is Vapor mode is an opt-in, performance-oriented compilation mode for single-file components. So the keyword here is that, first of all, it's opt-in. Second of all, it's a compilation mode, which means it's not some new API that you need to learn or some new way to write a component. It is the same syntax, the same APIs. It's just that the compiler will do something different to make it more efficient. So at the beginning, we do intend to only support a subset of the current Vue APIs. So namely, it will start with composition API and script setup only, so that we can make sure we squeeze out the maximum performance possible. But the subset of the APIs that are supported will be fully compatible. It will work 100% the same with the way that you know right now. So technically, if your component uses APIs within this subset, you can just swap easily, choose which mode that you want to use it in. So a Vapor mode component can be embedded in any existing Vue 3 app. So this is seamless integration. You don't need to change anything. We will show an example of how to opt into it in a later slide. So at the very least, if you have a big current Vue 3 application, but you have some parts that are performance critical, you want to improve its performance, you can then opt into Vapor mode for a subtree of your application, so that that page will get better performance, while the rest can still leverage whatever existing libraries that you use. But the eventual goal that we do hope to achieve is freely mixed usage, which means you can use Vapor components in a normal Vue component, and you can then use the normal component in a normal Vue component inside a Vapor Vue component. So you can mix and match them across the tree. So to explain it a bit more about how this compilation strategy works, we need to go back to thinking about how Vue renders stuff. So in Vue 2, Vue has always retained the same reactivity system throughout Vue 1. It has always been fine-grained, dependency tracking-based reactivity. But the rendering strategy has been changing over time. So in Vue 2, we were using a pure virtual DOM, which means it's just the same virtual DOM that similar to what React uses, and it doesn't really do any compile time optimizations. Well, a little bit, but really not much. So the result of this is when we have a whole application with a bunch of components, we achieve fine-grained app level. So at the component tree or the app level, we achieve fine-grained updates by having each component track its own dependencies. So we are fine-grained at the component tree level, but inside that specific component's template, at the template level, it's coarse-grained, because the way virtual DOM works is it'll always recreate a new virtual DOM tree and then diff it from the root, right? So the cost of recreating virtual DOM nodes and then walking through that tree for diffing is the overhead that we talk about when we talk about virtual DOM. And Vue 2 is constantly paying that overhead. So in Vue 3, we did the improvement that we did is compiler-informed virtual DOM. We did a lot more optimization at compile time. So we do talk about this in our docs. There is a page called Rendering Mechanisms. If you haven't checked it out, make sure to read it. So here, I'll only go over it very briefly. There are two major optimizations that we do. The first is patch flags. Essentially, for each binding that you write in your template, we encode a binary flag so that the runtime knows exactly what kind of updates this specific node needs. And the second is called block tree optimizations. So we divide a template into nested blocks at vif and v4 level. So these are structural directives. And inside each block, the node structure is known to be stable. So we just flatten all the dynamic bindings inside each block. So essentially, previously, when you traverse a whole virtual DOM tree, you may have to traverse like 20 levels deep, where you have to do like 100 nodes. But with block tree, you can theoretically compress it to make the traversal cost proportional to how many dynamic bindings there are in the template. So this makes it semi-fine-grained at the component level. But it's still not completely fine-grained, because we are still paying the overhead of recreating virtual DOM nodes. And this creates additional memory pressure, and we're still not completely eliminating the cost of walking down the tree and compare things. So Vapor mode is a compilation mode that takes inspiration from a new framework called Solid. And on the left, we see a very typical Vue component. This is the most basic a counter component with a button. And it's just using the normal script setup API that we know. And on the right, this is the output. So first of all, in Vapor mode, because we limit the subset of APIs you can use, there are a lot of assumptions that we can assume. For example, the component can be compiled into just a simple function call. So this even reduces the need of the existence of a component instance, which is in fact one of the most expensive things in large Vue applications. When you have 1,000 Vue component instances, the memory overhead and creating these component instances, creating its internal proxies and all that, we can actually drop that. So this makes component a not zero cost, but make the cost of component abstraction much, much, much cheaper. So you can stop worrying about whether I'm having too many component instances in the app. The second thing is we abstract all the static parts of the template into a string. So this is specialized for DOM rendering. This is to note. So Vapor mode is specialized for in-browser DOM usage. So we create a new instance of this string template, which is extremely fast, and then use Vue's fine-grained reactivity system with ref and effect. So think of this as watch effect equivalent. Inside the effect, we directly set the text. We instantiate the DOM itself, locate the actual button that we want to do bindings on, and then inside the reactive effect, we set the text. So this effect will track the count that we're using. And every time the count changes, we directly go to just, say, set the text on the button. There's no generating a virtual DOM, then trying to compare it, then finally figuring out, OK, this button's text needs changing. There's none of that. It's just going directly from change to, boom, set the text. So eliminating all the intermediate steps of figuring out what changed and directly encoding it in the generated code at compile time. So this is also a helper on getting the event handler bounded. And you can see all of these are actually living in the same scope. So there's very little that the compiler needs to do, very little magic that the component needs to do. Because I hope this also shows why we are only supporting script setup. Because script setup, the syntax here, is what enables us to compile it into such an efficient format. Because they all live in the same scope. So this allows us to essentially implement rendering with fine-grained rendering down to the block or even binding level. So we'll still try to benchmark, compare between block level granularity and binding level granularity to find the best possible rendering strategy, but this is the general idea. So some preliminary benchmark. So based on JS framework benchmark. So this is only one benchmark, and it's not really, this number will probably change when it finally lands. So this is all just tentative numbers. Don't take it for the word of truth right now. But the general idea during prototyping phase is that Vanilla.js 1.0 being the baseline, and these are standard deviations. Vapor is 1.08. Vue 3 currently is 1.25. And Vue 2 is 1.82. So these are lower the better, obviously. Memory usage, Vapor probably uses less than half the memory that current Vue 3 rendering strategy uses. So that's also a big improvement. So the way for you to actually use it is very simple. So name a component .vapor.vue, and it will be compiled using Vapor mode. That's it. Then you import that component and use it just like normal. If you use a feature that's not supported in Vapor mode inside a Vapor mode component, you'll get a compilation error. It's telling you this feature is currently not supported yet. Another way to use it, so this is opting at the component level. So this means you can just use this in any existing app you currently have. But you can also opt in at the app level. So use create app, but import it from Vue/Vapor. And then import your Vapor app root app, Vapor mode root app. An app created this way completely forgoes virtual DOM interop. So it doesn't even need to pull in the virtual DOM related code at all. So a component written this way, an app compiled this way, will only include Vue reactivity and the vapor mode runtime helpers, which are extremely lightweight. So a component compiled this way probably weighs around 5 to 6 kilobytes. So that will make it suitable for, say, building one-off embedded widgets as web components embedded on any page with a very low baseline runtime cost. All right, so that's it for vapor mode. So let's go into some ecosystem updates. Obviously, I don't need to repeat this, but Vite matured in 2022 and adoption exploded. It was a great year for Vite, and you heard me talking about it in the video leading up to this. And Volar.js, this is Volar, which is our official language tool, which brings all the enhanced IDE and TypeScript experience you now have with Vue 3. So we're extracting the core into something framework agnostic, specifically designed to deal with file formats with embedded languages. So the old Volar extension will be moved to the repository Vue.js/language tools. So to just more clearly indicate what it does. In fact, this move has already happened. Johnson will work on it full-time with support from Stackblades. So to focus more on improving Volar.js and in turn improve all the support for Vue and other things that may depend on Volar.js in the future, for example, Svelte or Astro or I don't know. We hope to see more adoption in that front. And VitePress, how many of you have used VitePress? Not many. How many of you have used VuePress? Okay, so VitePress is essentially the spiritual successor of VuePress, with the main difference being that it uses Vite instead of Webpack and Vue 3 instead of Vue 2. So we do have a VuePress Next project that's previously being in the works, but we decided that VitePress is, because it's a fresh ground up without the burden of having to maintain design compatibility with old VuePress, it overall provides a much leaner and faster implementation for both DX and the generated sites. So we've been hard at work trying to fixing bugs and finalizing the default theme styling, and VitePress 1.0 is coming soon, so stay tuned. We also have some great advancements in Vue 3 docs translations. So we already have simplified Chinese and Japanese completed. There are also two other languages, Ukrainian and French, both crossing the 50% completion rate. So they're already deployed on official Vue domains. So if you are native speaker of these languages, or there are other languages that are looking for collaborators, help us translate docs into more languages. You can find this link in the slides share later, or you can go to our website and look at the language dropdown. There will be a link taking you to the action steps that if you want to join translations. We announced the certification program in collaboration with Vue School. So this will be a program where it allows you to go through a bunch of tests and get a certification verifying your capability as a Vue developer. So this will be coming soon. I think Vue School is hoping to launch this in March. So this is another thing I want to mention. And then a question that a lot of people were kind of asking around. I've also mentioned this quite a few times in the past. The end of life for Vue 2, the end of support for Vue 2 is December 31st, 2023. That's the end of this year. So if you have a project that is currently using Vue 2 and intends to use it beyond this date, we wrote something up on the Vue 2 website detailing your options. So there are different options, right? So you can choose to upgrade or choose to stay on Vue 2. Both are viable. So make sure to check out the article. If you go to v2.vujs.org, we do have a banner that links to a page that gives you these options. And if you do intend to stay on Vue 2 for the long term, you can purchase paid extended LTS in partnership with Hero Devs, so that you don't have, so it's essentially a decision between whether you want to pay the cost of migration or do you want to just stay on Vue 2 with the ease of mind. So it's really up to you. And either way, we want to make sure like all options are possible for Vue 2 users. So And then there are more Vue conferences coming up in 2023. Not just this one, we also have Vue.js Live in May, that's in London, May 12th. And then VueConf US, May 24th and 26th in New Orleans. And VueFest Japan, which is going to be announced. I think the organization work is being planned right now, and we'll have a date announced later in the year. So if you happen to plan to travel to around these places later in the year, make sure to keep an eye out. And I believe VueConf US and Vue.js Live's call for proposals are already closed, but you can try the Japan one, maybe. And that's it. Thank you very much. Okay.
Thank you so much, Evan. It's always nice to hear from you about the upcoming upgrades and improvements to the Vue ecosystem. Who's excited about Vapor mode and faster build and test setup? I mean, come on.
Thank you. Okay.
Thank you so much.
Yeah, you're not going to hear what he says. Soundproof curtains.
Huh? What?
Yeah.
What's up? Ah, hey, here we go. Yeah, welcome back to the Vite panel, folks. And
Okay.
and I'm very happy to introduce our first, but not the last, obviously, panelist. Make applause for Patak.
You trying to escape? If you want to leave your bag in the speaker room, you have time.
The CMAC was on.
Just go through that door and go all the way through, and you'll see like benches.
Mike. Is it?
They're coming.
Is it? Okay. It's all. Oh.
Hello? Wow. It was turned off. That's okay. Now the slides.
Did you see the Discord channel?
Yes.
The one with the for the Vite panel.
Welcome
in case
to
you wanted
the
read
Vite
through any of
panel.
them. If not, we lost them on
Was
stage.
meant to
but just
do
in
a
case.
talk about the Vite.
JSWorld.
A full talk. Given that we have Evan
Oh, right.
here with us and also other 9 team members, so we better do a quick introduction and let
what is it?
everybody come into the
JSWorld.
discussion. So, I'm
me,
Matías
like, invite you or
Capelletto, also
something?
known as Patak. I'm part of the Vite team. I work on StackBlitz and open source. And that is Zorro, one of our 3 cats.
I don't have you as a friend. Oh my God, we're not friends.
Vite has 2 main parts. One is optimized build using rollup. And the other one is instant dev server, like we use an unbundled approach. And this give us a
9, 5, 8,
scalable
9.
hot module replacement
Search.
that I think that
Oh, shit, yeah.
most people here have experience already. Like, have you used Vite before? Woo. Okay. Yeah.
No, because it's searching for
And
friends.
Vite
isn't it?
provides a stable API, like we follow standards where possible.
Yeah.
But if not, we provide like other useful things like globing imports and rich features like TypeScript work out of the box,
And
CSS,
questions,
etc.
so-
And it's like we
No, 'cause
have
it's
like a
invite members,
rollup-based
that's why.
plugin API, and these have
I'm not an admin
allowed
here,
framework
I
authors
can,
to get involved in Vite provide like great plugins
Just.
and actually get involved in the development of Vite. I like a lot how Rich Harris put it, that Vite is starting to be like an infrastructure layer.
If I add you as a
for
friend
these
first,
frameworks.
then I can.
And it's also a common base for a lot of innovation in the meta framework
5?
space. We
What did you
saw
say?
today
5?
a lot from Nax, and also like
9, 5, 8, 9.
Kit, Astro, Solid
9,
Start, Quick
5, 8,
City.
9.
There's like a lot. Redwood, the last one, they are looking for testers, so you should check their integration.
What is this doing?
And Vite is also powering a new generation of tools and features. We saw yesterday the talk from
damn it.
Storybook and
Why
how
is
it's
Discord being-
improving. But it's also lowering the barrier for new entries. For example, Histoire and Ladle, they
because
are
this, like-
other takes on how to do stories development. And we have Vitesse, that is now a great alternative to Jest. And we saw also Playwright and Cypress. Both of them has component testing that are using Vite internally now. And this is just
5,
like
9, 8, 9.
some of them. You can watch my
Search.
ViteConf talk on the
Search
ecosystem.
far and wide.
More information. And Vite can also
Oh,
be
shit.
seen
9,
as
5, 8,
a
9.
curation
Damn it. 9,
of other tools
5, 8,
in the
9.
ecosystem. A big shout out to Rollup and ESBuild that are powering Vite
No, it's
internally.
like, what, you're not meant
And
to have friends?
also,
9, 5, 8,
for example,
9.
we started using ESWC now in React for very big applications.
direct message,
There,
search for
it
friends.
makes sense. The trade-off makes sense.
Uh,
So we are going to continue to evolve the tools that we use or how we use it. Maybe, for example, we could replace post-CSS by Lighting CSS later this year.
Go to the
So
Friends tab.
for our users, we are going to provide a stable API.
No, it is my.
and these
Well, no,
changes should
JSWorld
be
is not my account.
painless.
Find your friend, sync your context. No.
And yeah, I wanted to show like the trajectory of Vite. It's hard to believe that V2, Evan, you released it like 2 years ago, not even 2 years ago. And
Whenever the
at
screen
that
opens,
point,
but
it's
we'll
almost
write you when it starts. We will
nothing.
sit on the edges.
And in
by
the
way.
first
That's
year,
really-
it
Alex,
got to
feel free to tell
500,000
that to the others.
NPM downloads.
Besides that, no place rules.
And from
So
there,
when you
the
sit
past
down,
year we released
the chairs on the
E3,
edges are me and Alex, and
E4,
you're in
and
between
now
us.
is
That's the only
at
rule.
3 million NPM downloads. This is already a quarter of Rollup downloads, and it's around 10% of Webpack at this point. So for like a tool that 2 years ago was almost not in the radar of anyone, this has been a massive adoption. And I want to do a big shout out to Vitest that it is even more impressive. Because 1 year ago,
Discord's a pain in the
Vitest
ass.
was not
Should be
even
easy.
here. And in 1 year, it got to 1 million NPM downloads weekly. That is like double the adoption rate of Vite. So it's impressive. Yeah, and one of the main maintainers of Vitesse is also going to join us in a stage here for the panel, so that will be good. So, the Vite team. Evan, you released V2 after a massive sprint. Like, it was impressive to see the way he developed
9,
V2.
5, 8, 9.
And after that, Vue is also
That is you.
huge
You have a friend
project,
request.
So he needs help, and he created the Vite team that has been growing also since then, these past 2 years.
So
Me,
now,
Anthony
maybe
Fu, Arno
it
Beret,
allows me to
Poyoho,
add you.
Shinigami,
Send
Safi,
you an
Jorn,
invite.
Sodatia,
Joss hasn't
Dominic,
already done
and
it.
Alec are now in the team. And
So he could
yeah,
be stressed out.
all this work is possible because
Now,
of
invite
sponsors,
members.
and also there are companies that are
Yes.
directly
That was easy. We had to be
investing, like
friends
I
first.
work at Staglit, and he works for Nax.
But now we're
Jorn
friends.
has the Creator of Astro, and Sodatia works for Vue directly. And we work with a very big community. And right now in the repo, there are 700
Yeah, just in case you
contributors,
wanted to like start speaking about something like that.
we have processed
Covered if there was any
12K
topic of interest
issues.
that was like something you
There
wanted to talk
are
about.
95%
we can
of
ask
them
them as
are
well, but, like,
resolved,
just-
like closed or merged. So if you go to the repo, you're going to see that there are 400 open issues. That seems like a lot, but like the activity is a lot. That is why there is so many issues. But as how Dan Abramov said yesterday, if you want to get involved, there are 450 issues open, so please get into that GitHub tab and help us with triaging. Is the best way to get started with us. There is we love contributions, and we are going to help you get involved. The repo now has more than 50K stars and is in the top 150. So Vite is not the only player in this ecosystem. Obviously, there are tons of repos, interconnected communities from all the tools that we use. ESBuild in particular, they have a huge community now, the same for Rollup. And there are Rollup plugins and Vite plugins, framework plugins, all the meta framework and the tools we talk about. And they are all the maintainers from all these projects get together, they work together. There are PRs and issues going everywhere around here.
Oh, yeah.
So it's really interesting to participate, not in one project, but it's also cross-project and with cross-pollination. And we were able to scale, particularly this last year of growth, because of Vite Ecosystem CI. Shout out to Dominic Shi there. And what we can do with Vite Ecosystem CI is running on demand the CIs from a lot of the biggest projects in the ecosystem. So we have a PR, for example, that we don't know if it's going to break someone, and we can run it on demand and see directly if it's going to break someone or not before even merging or before releasing. Now we released it 4.1 last week, and now we know that all this is all green. Not only our CI, but the CIs of all others. And it has completely changed how we work. Before there was a lot of DMing people, and now we can directly have a complete picture. And shout out to other projects, Storybook, Vue, Volar, that are also or forking this setup or directly doing their own.
Great, so yeah.
And yeah, this is just some pretty logos. This is not even the full picture of all the projects that are involved. And a lot of you or the people that I met here in the conference have tons of stories of collaboration. And yeah, I would say not only in Vite, choose whatever community you like, get involved. That also help us a lot if all the projects around are better. So then let's welcome the Vite team. Evan, you and the rest, you are going to help me?
Yeah, of course. Yeah.
Whatever works best.
Oh, Jesus.
I'm going to enter here too.
Feel free to introduce them when they come around.
Okay. I need to look.
Oh.
I think there. Wow.
Here we are.
Is my mic on? Oh, it's on
Yes,
now.
it's on.
Playing games earlier, I heard on the live stream. Oh my gosh. What an amazing amount of talent on this stage. And I'm not talking about me and you.
Yeah, I know.
Where in the world have you seen so much talent on the one stage? Absolutely incredible. Give it up one more time.
Maybe should we do some small introduction round?
Yeah, because do you know all their names? I just know their avatars.
Well, I know a few for sure. Maybe that guy here.
Yeah, I've seen him before.
I mean Anthony. No, yeah, maybe let's just do it clockwise. Yeah. And yeah, feel free to share the mics. They should work.
Is it working?
It's working.
So I'm Arnaud. I live in Paris. I've been working with React for 4 years, and I try to improve React support in Vite.
Nice.
Hi, I'm Safired. I live in Japan. I worked on stabilizing the Vite. For example, fixing some regressions and quickly. Yeah. Yes.
Does it work? Yeah, does work. My name is Vladimir. I am a Vue.js developer, but I'm here because I'm a core team member of Vite, and I maintain this package.
I'm Dominic G, and as you see this logo, I'm making Vite plugins Svelte, and I also make Vite ecosystem CI, where Matthias also had some lovely words earlier. So I live in Germany, and I'm a freelancer by day, but by night I do open source, and it's great.
Hello. Hello. I'm Evan.
That's it. If you don't know me by now.
Okay, my name is Destiny Fu, and I'm working on the Nux team. So I'm trying to be the bridge between Nux and Vite. Yeah, that's all.
Hello, I'm Christopher Quadvig, better known as Shinigami, maybe. And I'm the core maintainer of Faker.js, and I joined the Vite core team like 2020, I think. And I'm using Vite and Vitesse in all my projects and so on. And also I'm a heavy user of Elk and so on. And I do QR like there and so on. Yeah, that's me.
Hello everyone, I'm Hao Chunjiang. I live in China, and you might have known me by my GitHub username, SodaT. I work for Vue.js full-time and contribute to Vite also. I have been maintaining Vue CLI for the past few years, and now I'm working on bridging Vue and Vite. That's it.
Hello, I'm Bjorn. I'm from Malaysia, and you might know me as Bluey on GitHub. I am currently the core team of Vite and Svelte, and also a core residency of Astro.
Yeah. I'm just here to talk. You know who I am. So we had some questions up in the Discord server view. If you want to ask these talented people any questions, you still have time to post some questions there. But first of all, before we take questions, is there anything that you would like to share? Any of you that are doing anything that you want to say, hey, I'm working on this, it's really cool, or you want to share with the audience? Anyone want to share? Yeah, go ahead.
It's my first time in the front of more than 30 people on a stage.
That's good to know. Anyone else want to share anything that you're working on that it's cool? I mean, everything's cool that you're working on, but, you know, they're all shy now.
Maybe we'll talk about some more projects, but feel free, please.
I just wanted to say we're making this small little thing called Vite.
All right.
No, that Anthony showed quite a bit what he was working on.
Absolutely.
That's very true. But Anthony never stops working. He's like sleeps typing. Okay.
Can we start?
Yeah.
All right. Then let's get on with the first question that was asked, and it is, what is the biggest achievement that you think Vite has achieved?
Thank you. Yeah, so first of all, I think it's amazing because last time I was in Amsterdam, Vite didn't even exist. And today it has over, what, like 2 million? 3 million, oh, already. That's per week, right? $3 million per week. And it's all still growing fast, and we have a lot of contributors. And I think more importantly, it has developed into its own ecosystem. It's no longer just a subsidiary project under Vue, but it's now a piece of infrastructure level project that's shared across a lot of different frameworks. We're seeing a lot of meta frameworks built on top of it. So I think, yeah, I think the biggest achievement is we started with this simple idea and made it into something that can benefit more people than it was originally intended to. I think that's what makes me happy, because ultimately I created Vite with the original intention to make the lives of Vue devs a bit easier. Then I realized, okay, this can actually also make maybe a React dev's life easier. So in a way, it maybe also helps Svelte or Astro or anything that depends on top of it. You know, if from a like for-profit company's perspective, they'd be like, why do we want to help our competitors, right? But from my perspective, it's not really about competing. It's really about if you have a good idea, why don't you make it benefit more people, right? So I think it's a good example of how we can leverage the power of open source and just make everyone benefit. So.
Anyone wants to add something?
When Vite started, I was working in a company and working with Webpack 4 and Vue 2. And then always when I needed to spin up the dev server and so on, it took like 1 to 2 minutes. So always I get to go coffee. And then Vite came out, and I'm a heavy TypeScript enthusiast, so I was not sure in the first place if Vite is the right tool, because it's not type checking and so on. But then there was Vue.js, and that is checking types before the dev server is spinning up. Oh no, the build takes place. So yeah, I learned that TypeScript is just only important for when you ship to production. So when you're just developing, it's okay to have some errors. And then it was blazingly fast, and I couldn't get any more coffee because of that. And then the plugin ecosystem was also very nice. There started to pop up some plugins like Vite Sleep that helps to yeah, spin up the dev server not so fast, so you can get a coffee. Yeah, that was my story and first touch with getting into Vite. And what I also love about Vite is that it's framework agnostic. So it's not only Vue CLI replacement, but it's also used for Svelte, Astro, and React, and everything else. And I learned so much, folks, around the open source ecosystem via Vite. Yeah, that's nice.
I'd like to add that, like, Vite has an amazing team of different skills and people. Like, we are very diverse. Like, the frameworks that build on Vite are very, very different. Like, Quick and SvelteKit have some things in common, but others, they are vastly different. Nuxt has very different approach, but we all work together to make it happen, and it just works. Like, this benefits everyone, and we just understand and do it, and this is great about open source. And I really hope more projects follow this approach. It's working great. It gives everyone an amazing productivity boost. So everyone can contribute. Like, I'm more than 40 years old, and for the first 20 years of my life, of my professional career, I didn't contribute to open source. now I'm sitting here with very smart people and sounding smart, but like I'm one of you guys, really.
He's like, damn, who put me on this stage? Okay, do you want to, anyone else? You ready for the next question? I like this next question. Is Vite going to support import maps and module federation? First party, not community plugins.
So I'll speak about import maps. So that's something actually been on my mind for quite a bit of time. So it should be relatively straightforward as to just add native import map compatibility. In fact, I consider it a bug to not work with native import maps at this moment. So that's an obvious thing that we need to fix. And so module federation is a much bigger topic. And the short answer is no. In the short term, probably there won't be first-party module federation support because the whole construct itself is very deeply tied into the Webpack model. And at least for this stage, if there is a userland plugin that is able to work, we would prefer to keep it that way. We may consider looking into it in the future, but in a way we don't, I think this ties into our the position of Vite as a project versus Webpack, right? People always kind of think, oh, Vite is here to kill Webpack. That's not the case, right? We do compete in a certain, there's a lot of overlap, and in a way they do compete, but it's not Vite's goal to completely replicate everything Webpack has to offer. Right, Vite, if we can, say, support Vite's current user base really well and cover maybe 90% of use cases, and there are 10% cases where module federation is your deal breaker, then it's fine to go with Webpack. And there are interesting alternatives to Webpack that's also coming up. So in a way, like we won't say chase module federation because Webpack supports it, we need to have it too. We tend to consider how does it fit with how Vite works and what is the need from Vite users, and how does that fit with our resources. Is it worth it to say, if we have to introduce major architectural changes in order to accommodate module federation as a first party feature, maybe that's not worth it in the short term. So it all kind of ties into the actual user demands and the amount of alternatives out there, right? Because Webpack is not dead. If you really, really need module federation, you can still use it. So
it's a great answer.
I think something that is important regarding that is that, at least personally, I will not like Vite to become the next Webpack in the sense of having 98% of like everyone using it. It's great to have competition and alternatives to also learn from them. And also, it wasn't that beneficial for the ecosystem that packages were developed directly for Webpack instead of for like Node. So at the beginning of the life of Vite, we suffer a lot with bug reports that say, like, my package didn't work. And it didn't work because it was broken. Jorn did a great talk about that, and the ecosystem have improved a lot in these past 2 years. But I think that it will be great to go to a future where we have a lot of tools to choose from.
Good.
All right, going for next one?
Yeah, the next one's a bit weird.
It's a bit cheeky, actually.
Yeah.
Why don't you rebuild it using Rust?
Yeah, that's a good question, right? So there are a lot of different ways to think about this. The first is, when you compare JavaScript and Rust, obviously you write it in Rust because you want performance. The question is, first of all, how much logic of your whole development model actually depends on computation-intensive stuff? And then there also ties into userland plugins. I think the more critical question is how do you interface with userland plugins when you use Rust? So for example, a lot of you probably know there is a pure Rust-based Webpack alternative coming up that's called RSPack. And I've actually checked it out, talked with their maintainers a little bit, and the solution, so I asked them, how do you support pure JS plugins? And the answer is, in order to get the best performance, they actually have to replicate a lot of these Webpack plugins in Rust itself and then compile it with the main binary itself, right? So that's not a very ergonomic thing for the user because now the implementation of the plugin is completely in control of the bundler maintainers, and you don't get to actually hack into it, look at how it works. And then there's also the problem of when you do have to use a JS plugin, there is the message passing cost between, so you have to interface between Rust and JavaScript. There is always this cost of passing data around. And then if, say, you have a big application, every piece of your code actually has to go through still has to go through a JS plugin, then that JS plugin becomes your new bottleneck, which is not really solvable by Rust itself. So there is a challenge of, when you think about this, the reason ESBuild is extremely fast is because it supports a limited set of features so that it can stay in native land as much as possible. It does support JS plugins, but again, when you use JS plugins with ESBuild, you will notice that your JS plugin becomes the bottleneck. It just slows the whole thing down. So in the way that we see the usage in Vite today, we have so many plugins, and a lot of the frameworks that's based on Vite, for example, Vue or Svelte or even React, right? A lot of the compilation still happens in JS land. So, and then there's a lot of the module resolution, the way we load modules in the browser, we're already leveraging native ES modules, right? So the actual JS logic in Vite itself, a lot of them is orchestrating the plugin runtime and then doing some module resolution. So there are areas where you can improve by rewriting some of them in Rust, but it's not going to, say, giving you this like 100 times or like 700 times faster kind of experience that you would expect. Yeah, so it's so again, like I agree there will be parts of Vite that may benefit from rewriting Rust, but the benefit may not be as big as you expect. So it again becomes an engineering problem because you need to think about, is it worth it to invest all the time to rewrite these parts in Rust, but maybe with very marginal benefits? Or do we keep it in JS with the added benefits of you can iterate faster, makes it the contribution barrier lower because there are more people who are able to understand your code and contribute. It also allows us to move faster as a team because you know, having to mix two different languages in Rust is, you know, noticeably a bit more higher cost to from a maintenance perspective. It's also harder to find contributors or maintainers who are able to help us in the future. So these are all things we need to consider. So it's not a simple problem of, oh, because Rust is faster, we should rewrite everything in Rust. It's there are really realistic concerns for Vite as a project to think about that.
There's a, oh yeah, go ahead.
Just speak into it, should be fine.
It's okay. Oh, okay.
It's great.
So yes, like I just want to adding a little bit of my opinions is that I think a great thing that Vite provide to me is that it introduced the idea of on-demand, and that means that it doesn't necessarily means that you will need a new language to make your app faster. Is that maybe sometimes you need to think another way. Is that you can do on-demand compilation, which will be much faster, even though like a full compilations in a very fast language. So I think that also like introduce a lot of new ideas or inspirations to our community to build the tools around Vite. So yeah, I think it really means that when the bottleneck is, and we can find some solution to improve that bottleneck, but it not necessarily means that we need to rewrite all the code base to some other language in order to get the performance.
I also want to add, like, so at this very moment, I think, say, rewriting Vite in Rust is not going to be a, say, good trade-off, but that doesn't mean this trade-off won't change in the future, right? Because we're always evaluating, like, what is a good time to introduce changes, and when would this proposal make sense maybe in the future? Because we know, like, during development, Vite is already pretty fast enough for a vast majority of cases. There are obviously areas we still intend to improve. For example, when you have a lot of modules on the first page load, that's one area we want to improve. And then there's the production build area where, say, because like previously we were thinking, oh, if there is a Rust-based rollup, then things could maybe the production builds could be faster, right? So I think the key idea here is every decision that we're making right now is based on the resources available and the whole, like, because the ecosystem moves fast, a lot of things can change. So we're always willing to evaluate a decision based on the situation right now. So thinking that Rust may not make sense for us now doesn't mean it will never make sense in the future. So from that perspective, Vite is a very, like, we are always looking at it, as long as we can preserve the same DX and improve it, we're always willing to consider what internal parts we can swap out or change to use a new implementation. But every decision has to be based on whether it's a worthwhile trade-off.
I want to add that, like, we are talking about an exception case right now, like this many modules on the first page is like 0.001% of production applications. Like, there are billions of pages and applications out there, and most of you will never run into this kind of performance issue where it would be worthwhile right now to invest in this. So we can still do this later and work on even more DX improvements meanwhile. Like, look at the tools Anthony showed today. And this is just the start. We have more ideas in that area, and you probably want us spending our time there and not like chasing Rust right now. So you shouldn't probably have 10,000 modules on your first page anyways.
Code split.
Okay, that was, yeah. That was a nice short answer. Good job. So I'm going to throw in a couple of questions mixed together here because I quite like them. How are you organized inside the Vite team? How do you manage to collaborate with such different time zones? Are there any times where you have to have a call to each other, discuss how to implement stuff, or is it all async via text?
I can get that one. So we work async, like in many open source projects. So time zones actually help because you can get different people to answer when the issue appears. And we collaborate a lot and like triaging and then reviewing PRs and trying to get as much PR to a situation where we know all the trade-off and we can make a decision. And we have regular meeting with all the people that you see here. And we have a board that is public. You can check it out. And then we have priorities, and we start by like the P5, P4, P3, and when we run out of time, then we evaluate in the next one. But in these meetings are like really productive because almost, again, all the trade-offs are already on the table, and we can make a high-level decision and have a consensus there.
Is this the first time some of you have met each other in person?
Oh,
Yeah?
wow. Yeah.
It's kind of cool, right? Like, we all work together, but we've only just met. Story of people's lives nowadays.
Well, maybe then let's just ask that question because it fits so well. How do you enjoy having so many Vite members attend a conference in person so far?
It's great.
Good answer.
thanks a lot to the organizers again. That it's amazing that they managed to get us all in the same room.
Yeah.
I'm going to jump to a V-test question.
Yeah, please, please. There are lots of, actually.
Any idea when will V-test be production ready?
Well,
no pressure, no pressure.
No comment. Oh, we don't know. It's if maybe you've noticed a pattern with Anthony's packages. They don't usually release a V1 version. Maybe all at once. Right now, there are no real plans no real timeline to release it. But I don't know. It will be ready when it's ready. I guess is the answer. I really like making breaking changes. So if we release a 0.1 version, then in 2 months we'll have version 32, 33. So.
Okay, yeah. Yeah, for me, I think the first thing is that I think we can consider Vite as being production ready, but it's just not starting the version as 1.0. And I think current phase is that for me, I would like to have the changes being the features or the changes like being delivered faster. So that means starting with 0 point something is that means that when the minor version changes, it means that we may contain some breaking change, even though the breaking change might not be affecting like 99% of you, but we still be careful. But also like this can keep us to iterate faster, to try different ideas. And it just means that when you see a minor bump, you just be careful to read the notes to see if that breaks something you use, but like most of the time it doesn't. And I think at some points, maybe for the marketing process, we should probably go with 1.0, and then you will probably see like 2.0 next week. Okay, yeah, that's all.
Yeah, think about Jest is already on 26 or something, right? So
29.
Even think of Vitesse as like if you go, think of Vitesse as like 0.34 or something.
27, something around.
So yeah, just think of it as same Jest version number. It's the same idea.
I can say Faker.js and Prettier Plug and Pack and some other tools I'm maintaining are completely written in Vitesse, and also Cypress some stuff, sorry. I may port some stuff to Playwright maybe.
Yes!
But yeah, so Faker.js is completely tested in Vitest, and maybe that yeah, makes you confident to just use it as production ready.
I'll add to that. I just recently migrated the whole Vue 3 core test cases from Jest to Vitest in one afternoon. And I wrote a script myself to do some more mechanical conversions, but 99% of the test logic remains exactly the same. I actually have simpler config, and tests run faster when I disable threads. And yeah, it was a very pleasant experience, and our CI got faster, local feedback got faster, and everything that we saw in Jest has an equivalent. So, so I would say I consider it production ready, more than production ready. So don't really. I think when you are evaluating whether a thing is production ready, it's more about what your use case is. And from the past few versions, take a look whether the features that I care about, is it working correctly? Did it go through abruptive changes? What kind of changes are you actually landing between these versions, right? If, say, over the 4 to 5 versions, really these changes don't really affect me, then to you, that thing is production ready.
You said you have a script for migrating from Jest to Vitest. Would you like to package it?
Well, it's a bit specific, but mostly it's about, say, Jest has a bunch of globals like Jest FN or like Spion, something like that. So I just wrote a script to convert those to vi.fn and then import it if it doesn't exist. That's it.
There's also a project called Vitest Codemon or something like that right now in development from the community.
And if you just want to try, you can also just alias Jest to Vitest and see if it works. You would be surprised how many times it just works, honestly.
Clever hack, so to say.
Okay, I think we'll go on an interesting question going back in time. What were some of the biggest challenges you faced along the way with Vite?
For Vite, I think the biggest challenge in the beginning was probably getting people on board with the idea of ESM only, because Webpack has the history of supporting a wild amount of just like things that shouldn't work, but it works in Webpack, like mixing ESM and CJS, doing like inline require calls in an ESM file, and even if you package things wrong, Webpack still makes it work. So people's expectation of what considered should work is, I don't want to blame Webpack, but like a lot of users kind of got spoiled by Webpack, thinking like even if some code is not spec compliant, it should still work. So I think the biggest challenge in the early days of Vite is every time we try to sell people on it, people are like, but my code works in Webpack, it doesn't work in Vite, you're not doing it right. So we have to explain, okay, like this is actually not our fault. Like, so it's an interesting process because the time Vite was starting to get a bit of adoption is also this still ongoing transition period from the whole Node.js ecosystem and front-end package ecosystem, moving from this wild west of like AMD, UMD, CJS, ESM, all mixed up together, with finally a push towards moving things more towards standard ES modules, right? So I think in the early days, a lot of people still kind of think of Vite as they want it to be a drop-in Webpack replacement when it was never intended to be. So obviously we had to make a bunch of trade-offs, and eventually we kind of catered to a bunch of needs, but like it was a process of like just gauging how much we should, like sort of how many of these workarounds or like edge cases we should cater to balance that between like getting adoption versus staying as close to standard as possible, but like not like, for example, like should we polyfill Node.js built-ins by default, right? That's also a thing a lot of people complain about because Webpack used to do that by default. And yeah, I think the biggest challenge is really just like, because Webpack was so dominant and people use it as a de facto standard as a comparison, and when you don't do something that Webpack does, they consider you are wrong. So we have to kind of overcome that mindset of convincing people, okay, like we don't have to do everything that Webpack does. Vite is Vite, and if you don't like this behavior, you can keep using Webpack. And I think that kind of worked because we still really strictly enforce that you can only use ESM in your own source code. You can, so we don't polyfill Node.js built-ins by default, and that didn't really like hinder its adoption, I think. So so I'm glad we stuck with some of those decisions, and it still worked.
I have one, but Anthony should answer. But another big challenge that we had is that Jest was not working well with Vite. And I think that is a great story to share.
What should I say? Okay. Oh yeah,
No pressure.
All right. Yeah, I think since I think the idea of Vite is so new is that like doing on demand and doing leaving like taking the responsibility of like have to bundle your code from your bundler to your browser, and where browser is actually more efficient. So with that part is that it doesn't work with the existing testing libraries like JS, and you have to have a different set of pipeline to do the transformations for your code to match with your application code that like served by Vite. So that kind making some like barrier for us to say Vite is production ready and you can use it to build an app. And the only missing part is that you cannot have a good testing for your application. So that's the thing we were discussing about which test runner we should recommend in our documentation. So that was in one like team meeting, and Bata come up with the name like Vitest, and it turns out that it's available on NPM. So that's we grabbed the name and built a package for that cool name. So yeah, and yeah, we're glad that we find a way to solve this and to actually make a tool that we kind being proud of and really happy using it. Thank you.
Just came into my mind. The coolest thing about Vitest and the Vite ecosystem is, for example, Faker.js is using Vitest and Vite.press for documentation and Vite for bundling also. And so I do not need to use any more Webpack or Jest or anything like that. And Docker Zyros, for example, as documentation. And now I have 3 independent ecosystem structures around my tool. But because everything is more based on Vite, my package dependencies or my package log is split more by half the size. So I have more, I have less dependencies that I need to manage and I need to download because everything is somehow based on Vite. And yeah.
I want to add one thing is that Vite help us think out of the box. And for me, I used to maintain Vue CLI for several years, so it's hard for me to say goodbye to Vue CLI and let it be in maintenance mode. But I think Vitest helps a lot in the process. I used to try to keep the ecosystem continue to work with even when Vite came out. So I even write a package called Vite.js, trying to make just work with Vite, and it turns out to be very hacky, and it's not a good option. So we end up not recommending it. And then Anthony created the Vitest, and so it's so I now then understood that. Maybe the best option is not to keep using the old tools, and sometimes a new tool, even with some manual effort to migrate your old code bases, is worth it, and it provides a better experience.
So the Vue community seems to produce more framework-agnostic tooling like Vite, Vitest, Volar, Nitro, etc., than other ecosystems. Any thoughts on why?
I don't think that's an intentional decision. Like, in a way, obviously there are, say, I think Jest was probably created internally by Facebook. It's not React specific, but it kind of got adopted widely. I think overall it's just thinking about the level of abstraction. A lot of projects in the ecosystem arouse from, like, all these open source projects typically arise from the developers' needs to solve their own problems, right? So when you're working with only one framework, it's very easy to come up with a solution that works only for that framework because it solves your problem. But as someone who my main job is not working on a specific application, I almost work at an infrastructure level now. Like that Vue is kind of like the lower level for higher level frameworks like Nux, and Vite is also relatively lower level for meta frameworks built on top of it, right? So I always tend to see the problem from a perspective where essentially, like, when I see a problem, I try to think which layer it is in, and try to think. You always want to provide a solution that's less coupled to. The fewer things it's coupled to, typically it's better, right? It's also from a maintenance perspective. Like even inside Vue core, there are layers of, like, the reactivity package is the lowest level thing, and then we have runtime core, runtime DOM on top of it, right? So a lot of times this kind of separation helps you to have a cleaner architecture in a way. So I guess that's a habit for me to always think about, like, if I'm building this thing, does it really have to be coupled with Vue, or does it really have to be coupled with whatever thing I'm working with right now? Can it be extracted into something that's reusable? It almost becomes a habit, like, right? The reason Anthony has so many packages is because every time he solves a problem that he has, he's like, this can be made into something reusable, and a new package is born on NPM. I think, I don't know why it's more common in the Vue ecosystem. I think if you look hard enough, there are probably good examples from other ecosystems too. But I think Vite just draws more attention to it because it's probably one of the more prominent examples that people can think of. But I think every framework should, like, try to do more of that. I think it just benefits more developers in the end.
Alex, I think you had a favorite question.
Oh, I quite have some favorite question, but there are quite some interesting ones. I'll go with these first. Favorite ones for the end. So another question on Vitest, actually. Can you give an update on Vitest performance? While migrating multiple projects from Jest to Vitest, we noticed that running tests is slower. The last release improved a bit, but Jest is still faster, according to the question. And thanks a lot for great work, by the way.
The dreaded question. Well, it's fast on my computer. I don't know what they are talking about. But there are several layers to unravel here. There is like two separate processes. When you are writing tests, you either write tests, and you probably should have a watch mode enabled. It's usually enabled by default. And it's super fast when you make changes. You see your test rerun, you make another change, your tests. Sometimes you don't see your test rerun, but they are running because it's so fast. And we are very proud of this workflow. We really like it. And a lot of people for the past 2 days came to me and said thank you for this, for the exact same thing for watch mode. But there is also a test when run in CI, which are actually running, and this can take a lot of time sometimes. And for the past 2 months, thank you for noticing, there was some improvements. It was, I wouldn't say improvements, they were more of bug fixes. Some funny imports where they shouldn't be. But yeah, we initially thought that bottleneck was worker initialization, but turns out it's really not. It's if you go to Vitest issues, you can reorder them by the most liked ones, and the first one that will come out will be Vitest is 3 times slower than Jest. I'm keeping a close eye on it. And there are some comments and from one specific guy who said that tests are running 3 times slower in Vitest than in Jest, but when he made one change, he aliased one of his node modules package to that was ESM compatible, that had a lot of files that piled up on each other. He aliased it to one file, and tests were the same as with no threads for some reason. So maybe sometimes the problem is not in Vitest. I don't think the architecture that we built is the problem, but we can certainly try to improve this performance. Also, model resolution takes a lot of time. I hope the new TypeScript model resolution bundler, everyone will use this thing, please, should improve and use extensions in the new imports. It will be like 30% faster. But yeah, I think Evan, when presented Vite for the first time, he said that there should be an optimization step for node modules, because if you just import for node module, it will start importing these hundreds of files, which will be slow, and which will be slow because of the network issues. But it also slow. But it will also be slow in Node just because it's 100 files imports. So yeah, maybe we can somehow improve the this part. But I know.
I would like to add the same thing I said earlier, like the runtime performance of Vitest is plenty good enough for most situations. And like if your CI runs in 80 seconds, then in 60 seconds, or even in 40 seconds, that's still bearable. But the great benefit of having like instant feedback of Vitest watch mode, it turned my life around basically. So try it. You won't regret. I promise.
I'm going to keep you on the testing question, but it should be a quick one. Is Vitest leaky between test files? For example, do I need to clear all mocks after all in a describe block?
It depends.
Told you to be short.
You can do that. You cannot do that. I think by default it doesn't clear mocks. There are options in the config to do this, but it tries to give users more control over how they want to do it. But yeah, it depends.
That was quick. Okay. There's another one. We briefly talked about how Vite is not a Webpack drop-in replacement, obviously. But the question is, will there be some kind of migrating guide how to migrate from Webpack to Vite?
I think there are a lot of community guides on there already.
Oh, sorry, from you as the team.
Us.
Yeah, to add that.
Copy paste.
Yeah, we can probably just have a page where just we list all the user land guides, because it's never going to be comprehensive, because different people have different Webpack setups. You can have wildly different Webpack configurations. So it's hard for us to give you a one-size-fit-all migrations. I say a create React app migration to Vite will probably be straightforward, but it probably won't work for a Vue CI app, right? So that's why it's hard to give you a one-size-fit-all kind of thing. But I know there was a project called there was a code mod project that can automatically converge a project, but it's targeted towards Vue CLI, because it's easier when you are using a like strongly convention setup, like a create React app or Vue CLI, because we know like what kind of setup you have. But if it's a custom Webpack config, we don't really know what you're using, so it's hard for us to tell you this is what you do, right? So.
I think it was Webpack to Vite. There was one like that, and also the folks from NX now have CLI to do some of that. But it's, as you said, like it is not a fit all. But also, like one thing first is that the Vite core team cannot do everything for everyone. Of like Evan always mentioned, the resources available. Like we need the ecosystem to do all the things. Even for our own documentation, we are thinking on, or maybe we shouldn't have the deployment page show how to do this in our thing, but it should be directly in the deployments docs of each of the services. So it is important that like the core team does Vite core, and then like all the ecosystem work on the rest. And also about the migration, like an automatic tool is interesting, but it's also really nice to start maybe fresh with Vite, really learn how it works, because it's not the same. So if you just convert, you're going to miss like all that learning period that I think is really important, because in the process, you may end up like deleting a lot of things instead of just like moving one thing to the other.
Yeah, yeah. I want to echo that because I just recently bought a new MacBook, and every time I buy a new MacBook, there is a feature that allows you to transfer your old data from your old MacBook to the new one. Every time I think about that, but I ended up not doing it because I want to set up my new machine from scratch, look at my old setup, and thinking about where I can optimize. And I often end up like switching things up using a new solution or dropping some old config that's no longer needed. And in that process, I optimize my setup. And I also have a much more solid understanding of my new setup. Like I know everything that went into this fresh machine. Instead of like maybe I carried over a lot of legacy stuff, I don't even know how it works now, right? So I just want to echo that sentiment of sometimes maybe when you're switching to a new tool, rethinking your whole configuration can actually help you start with a fresher, better foundation for your new project. Yeah.
So yeah, Patak and Ivan also already said, but I can just suggest to take your old project and then spin up a new Vite project with the template options, and then just moving some files over. At the start of Vite, or when I first participated in the core team, there are many questions like, why can't I move my index HTML to the source folder or the whatever folder? And it's just not how Vite works under the hood. And we always taught them, you cannot just put your Webpack old legacy project and migrate it just by replacing a Webpack config against the Vite config. So you need to learn some new stuff, and like Ivan already said, by doing so, you also maybe move out some trash and old config that is just legacy stuff, and you don't need it anymore. And yeah.
Also, like, just playing with Vite is absurdly easy. Like, you can just go to vite.new and play in your browser. You don't have to install anything. And if you want to test the templates, you can just use create Vite, like npx create Vite at latest. And I would also like to highlight create Vite extra by Björn. If you don't find the templates fitting your use case, have a look there. There are some that use Deno. There's some like low-level SSR framework starters there. So if you want to make your own, have a look there. it's really cool stuff. Like, I mean, we could basically talk all day about all the awesome packages that are already there in the Vite ecosystem. Let me just say I love you all for building.
Oh.
Thank you so much. Thank you, John.
Okay, a bit of a technical one here on your decisions. What was wrong with CJS modules? And what are the objective reasons we should all be adopting ESM? As far as I can see, all ESM has done is cause an incompatibility cluster and cause a divide in the module community where there didn't need to be one, don't you think?
What's the last half of the question?
Cause a divide in the module community.
So yeah, if you think about the whole CJS to ESM migration, I agree. Like the whole transition period is caused a lot of issues. It's kind of painful. Like even to today, publishing a package is hard, right? I think ultimately the reason that we need one is because CJS was something that Node.js just came up. It almost became a de facto standard, but one of the driving reasons for the syntax design behind ESM, which I initially kind of, when it was first introduced, I was in the boat of like, CJS is great, CJS is fine. Why do we need to introduce another module format? But ESM actually enables a bunch of interesting capabilities where, first of all, the syntax is more restrictive, but it's designed to allow easier static analysis. So you can more easily determine the relationship between modules. It's more deterministic, so which means for build tools and bundlers, it's easier to understand the relationship between modules. Then it's easier to do optimizations, like tree shaking. And in fact, the reason your bundle can be smaller is like if you use CJS, like Clojure compiler can do CJS tree shaking to a certain extent, but it's just because the extremely dynamic nature of CJS allows you to do all kinds of crazy things that can just cause the optimizer to bail out. It's just not as real. So ESM is more like sort of tying your hands up a little bit, but then you end up with a code base that's much more optimizable by tools. And also because ESM is written into the standard, whereas CJS is de facto standard that doesn't. It's an implementation detail to be precise that Node.js happens to choose. So from that perspective, we want to. Another reason is obviously ESM is now a natively implemented feature in browsers because it's a standard. It's now a native part of the JavaScript runtime in everything that's standard compliant. So it would, CJS by definition is Node.js specific, but nowadays even JavaScript runtime is not just Node.js. You have worker environments, you have Deno, you have other environments. But the common theme is all these new runtimes, they all support the same standard ESM modules. They don't necessarily support CJS. Most things that support CJS that's not Node.js only do it for Node.js Compact. So that's not a really good reason to stick to CJS. I think the transition period is painful, but eventually when we all move to ESM, it's going to be good. Like, in a way, the reason Vite strongly sticks to ESM is because we had the ability to start fresh. Like Webpack had to deal with all this interop stuff, but like the time Vite was coming out, the whole idea was to leverage native ESM. So pulling all CJS interop will inevitably make everything a lot more complex. Again, like slow us down, and also it doesn't improve the status quo because it will just allow people to keep staying in the mixed CJS ESM land. And for me, like personally, one of the reasons we stick strongly with ESM is I want to use Vite as a leverage to help push the ecosystem toward more just everybody just use standard ESM. That's one of the things I kind of have to intentionally push a little bit.
I want to say that CJS is not the culprit, actually. The real problem is the previous tries that we intended to make CJS compatible with ESM, or we intended to move our code to ESM based. And the mess is caused by that. And the old tools cannot just drop the compatibility layers previously. So there are a lot of issues with Babel transpiled ESM files and Webpack transpiled ESM files that are made into CJS. And it is because ESM is not a mature spec when it comes into the JavaScript spec. If Node.js does not fully support ESM until like Node 12 or 14. And then people just use all the custom fields for ESM entries like module field. And later, the Node.js team decided that exports mapping package.json is the way to go. And then we have a ton of issues regarding the module field, because sometimes people think it's an ESM file. Sometimes people think it's only for browser builds. And because at that time, browser already supported ESM, but Node.js does not. And there are it is a mess regarding to this issue. And Vite, as a new tool, we have the opportunity to just drop these malformed CJS files. They are not actually CJS because they intended to be consumed as ESM, but they are not actually ESM. It behaves differently. So we use Vite as a leverage to move the community forward, I think. And that's it.
I also like to add that when I started at web development, like CJS and ESM is definitely something everyone would have, and I wonder why is there two specs for JavaScript? Like, should be one, right? But I think the revelation comes to me is when I understand like why are there two. So friend Rixel taught me that actually CJS is not really a spec, like it's a runtime. It runs on runtime, so it's hard to know ahead of time that you're importing a module or something. And ESM, on the other hand, is actually not a runtime but a spec. So it is syntactical wise that you can analyze and understand what is actually importing. So there's no wrong with that. And the reason bundlers support ESM is because of the ability to analyze it. So compared to dynamic require with CJS, it's hard to optimize. And that's why from that on, I understand okay, ESM enables all this optimization. Maybe it's worth understanding why I should, when to use require, when to use import. And from there on, I think, yeah, the transition, although it's painful, but it is worth it because there's a reason. And I think that's a good reason to learn the nuances with it.
Yeah, I think what Evan said earlier about various runtimes adopting ES modules as their truth basically allows us to have these universal applications that you can just deploy anywhere, and this is a future that's worth working forward towards, even if we have this mess right now, and even if Node.js, they are not going to drop CommonJS anytime soon. There's just too many applications that's still needed because they never get updated anymore. The developers left for other projects and they are still running, so they have no time or no reason to just no longer support it. And if you build server-side only Node applications, be my guest, continue developing CommonJS applications, it's fine. But for the web ecosystem as a whole, building things in ECMAScript modules enables this universal compatibility. And if we agree on a common set of server-side APIs, we get the browser spec and the server-side spec, and we can just build applications and deploy them anywhere, and it works. and I want to have that, and it's worth working through this mess. We need your help. Like, when you find packages that don't pass Publint, please tell the authors, but be nice about it. Like, I've built packages that had errors in Publint, and I know a lot more about packages than I ever wanted to. So it is messy. We have to get out of it. It takes all of us to do it. So get started. If you have packages, use Publint, put it into pre-publish, and tell your friends, tell your mom. Do it.
All right, we have 3 more questions because time is running, or even flying, so we're slowly wrapping up. The first of these 3 questions is, and I think everybody can answer if they want to, what is the most amazing package in the Vite ecosystem, for you personally, that the core team didn't build? So the most amazing package that the Vite team did not build.
I think I can answer this. So I think in the ecosystem, there's like many interesting ones. For me, I think the interesting one is Vite Electron. So Vite usually is being used in the browser, but Electron is like a special case where a browser and Node runs at the same time. And there's great contributors in the ecosystem. There's not from core that made it work, even though it's like in Vite's own nature that it shouldn't have worked. So for me, that is like very interesting. I'm very, very interested to see how it goes from there.
Nice.
Yeah, I mentioned it already. This Vite plugin sleep was very funny.
I think one thing worth mentioning is a plugin called Vite Plugin Checker. So one of the things a lot of people just started using Vite, they complain about, like, why do you only transpile TypeScript that does not do type checking? And the reason we don't do that is because type checking by itself is incompatible with the on-demand transformation pipeline of Vite itself, because type checking by definition needs knowledge of the whole module graph, while Vite only processes modules one at a time when they're imported, right? So jamming the whole type checking or, like, say, ES-linked linting into this on-demand model will inevitably slow it down because the two is just incompatible. So our recommendation is always to do static analysis that requires parsing all the files together in a separate process or thread. You can do like manual TSC watch mode, or you can use Vite Plugin Checker, which can run TSC and ES-link together in a separate process.
Yeah, I like to add a twist. Like everything Vite builds on, from Rollup with its great plugin API to a lot of very small utility packages that, if we take them away, Vite would just break completely apart. They are so important for us. Like, so thank you everyone who builds low-level packages that are used in the Vite ecosystem. Also, like, thank you Prettier and ESLint and all these tools that make code bases cleaner. They are very important, and it's important you support them. Like, when you think the Vite code base is too large and too scary to contribute to, find these small tools. They need our help too. Like, look at them, help out where you can and want. It's very important.
Speaking of that, we definitely want to mention Vite is built on top of ES-Build and Rollup, right? So these are 2 extremely important foundations that enables Vite to be what it is. So these 2 projects deserve a big shout out too, and so their maintainers are also doing an amazing job. Yeah.
Any other packages someone wants to mention? Nothing.
I have one that is, well, now it's from a Vite core team member, but Vite plugin React SWC, Like at that point you weren't, and that was a community package and was at the right point, at the right place, so that was really, really good. So thank you for that.
All right.
He was going to speak.
Nothing to add.
Then up to you, Debbie.
Okay, so a couple of years ago, we premiered the Vue documentary here. Yesterday, the React documentary. When is the Vite documentary? The community have already given it a name. It's called Vite for Speed.
Well, Honeypot hasn't contacted me about that yet, but
Damn, Honeypot.
maybe they will after they see this.
They should.
Okay, yeah, it would be a very cool documentary. I'd love to see it.
All right, then the last question of today. And once again, I would really like to have everyone to answer after a short period of thoughts. So, in one sentence, describe what Vite is for you.
Could be just money or food or, you know.
And no, the technical definition doesn't count.
Fast.
That's a sentence, yeah.
Germans.
For me, it's ecosystem collaboration. Like, that is one of the main things also for Vite moving forward. Like all the feedback that we get from all the framework authors and inform how Vite progress.
So for me, Vite is my first opportunity to make open source and to contribute to tools I love to use every day. So yeah, that's it.
For me, it's being something like my child. I don't have, but I'm thinking about it almost every day and every time. So yeah, it's like my child.
Okay, so for me, Vite is this exceptional community of great people, and I happen to have to become a part of it, and it makes my day every day. It's a lot of work, but I enjoy it somehow.
For me, Vite is a very pleasant surprise that outgrew my wildest expectations.
Nice.
And I really appreciate everyone here for making it what it is today. Thank you.
Okay, you already said a good big word. So yeah, for me, I think is innovation. I think like the exist of the Vite is that really opens up a lot of different ideas or inspirations that we could have to build a tool, and this it's actually giving us a lot of good ideas to have a lot of improvements that we wouldn't imagine before. So yeah, I think that's the word I'm going to pick.
For me, I think Vite means collaboration, and I have to shout out to Matthias. By watching his way of doing the job in Vite, I see the possibility of collaboration between the other community open source maintainers, and it's enormous.
For me, the one word to describe Vite is experience. So it's not a user experience, developer experience. It's experience getting to know how all these people work. Matthias, he's an expert with the ecosystem. With Evan, he's an expert and an eye for DX, how to manage issues and open source in general. and of course many more experienced maintainers here that I'll have no idea, no way of interacting with them if I have not been actively in the open source. So the experience is definitely the main point for me.
I think I'll just add to it and say Vite has an absolutely amazing community, and I think that's what makes it so successful. So thanks to the community.
Okay, then I add my 2 cents in here as well. I think Vite is an amazing example of open source that also goes beyond the boundary of frameworks, and it really shows that it doesn't matter if you are into Astro, Svelte, React, Vue, whatsoever, that you can collaborate, and that it's not always about, oh, is this framework better at that? It's more like, yeah, as already some people saying, innovation and collaboration.
So I think we have to end the panel, which is very sad because it's been so much fun here. I don't think it's going to be possible to have us all here ever again. We might, who knows, like the same amount of people, the same, like who knows. But it's incredible to have this panel here. So like take this moment, take a photo, because you know you might not get this opportunity again. Some people are here tomorrow, so if you're around tomorrow, you'll be able to ask some questions as well in breaks and stuff like that. And yeah, we're all photos, love it. And yeah, I just want to say personally, thank you to you all for sitting here so long, for asking the questions, for paying attention, and for being part of this amazing community. Thanks to all our team who are absolutely incredible. Like I said at the start, the intense amount of like expertise on this stage is insane. You'll never find it anywhere. So big round of applause once again. Thank you, everyone.
All right.
Time.
Then see you all tomorrow.
Well done.
Good morning, everyone. How's it going? Woohoo! It is so exciting to be back here on this incredibly ridiculous stage. It's absolutely insane how beautiful this is, and I'm really grateful for all of you joining here today, and I'm also grateful for the organizers for this conference. So I want to make sure that we give them just another round of applause for bringing everyone together today and for the next 3 days in this wonderful venue. And then I also want you to get into the habit of kind of applauding for the next speakers as well. But before them, I want you to give a round of applause to yourselves. You showed up today, you're here, and you have the next 3 days to learn, and you're giving yourself that space to do that. So huge round of applause to all of you for being here. As Alex mentioned, I'm an engineering manager on the Angular team, and my primary focus is on the core framework and tooling. And some of you might know that I've also been here in 2018, which was the first edition of Front-End Love. And back then, I also talked about Angular. So joining the Angular team last year has been one of those types of career milestones that I've been looking forward to, and I'm super excited to be here to be representing the team as well. And today we're going to talk a bit about the work that we're doing to accelerate developer experience in Angular. And we're going to start with a story. It's about the American Air Force back in the 1950s. Pilots were having trouble controlling their aircraft, and incidents were on the rise. And they couldn't understand what was going on. They looked at the skills, they looked at the tech. Nothing was coming up, really, until they looked at the cockpit. And what was interesting about the cockpit was that it was created for the average person. But who is the average person? What they discovered is that in trying to fit the average person, it actually didn't fit anyone. And once they made this discovery, they redesigned the controls in the cockpit to be adjustable so that they meet the unique needs of their pilots. And that really laid the foundation of expanding the Air Force to women and building a more diverse and inclusive workforce as well. So you might be wondering, how does that apply to Angular, actually? Angular is a very opinionated framework, and we know that that's one of our strengths. But we know that each of you, like the pilots in the story, you have a different set of problems that you need to solve, and a different set of tools that you love using, as well as a different set of customer needs that you need to be serving. So just as the Air Force made those controls extensible and flexible, in the same way, we're building into the framework knobs so that developers can use it in the best way that fits their exact needs. And we want to meet developers where they are and reduce the friction of building great experiences on the web. One way in which we're doing that, and one of the first steps in doing that, is actually understanding what those needs are and really listening to what are some of the problems that you all have. And for those of you that have filled the annual developer survey, thank you so much for doing so. The results that we're looking at right now are actually the ones from the previous year, but we've just opened up the annual survey for 2023 or 2022, and it's available on the website as well, the angular.io. So please go check it out and submit your feedback. To our knowledge, this is one of the largest surveys out there with over 20,000 participants. And I want you all to know that we take this survey very, very seriously, and it usually influences our framework's roadmap. So if we dive a bit into the data, we see that you all are very happy with the productivity that Angular gives you. And you also are very happy with how you're able to keep up with Angular releases, as well as the UI components toolkit that comes with Angular and the tooling. But we also notice that there's opportunities for improvement. Specifically here, we're looking at debugging and profiling. So our team rolled up their sleeves and started working on this particular item. And over the past few months, we collaborated with the Chrome DevTools team to launch improvements to the debugging experience directly in Chrome DevTools. People from both teams worked together to enable developers to debug and profile web applications from the authoring perspective, in terms of the language and the source language and project structure, with access to information that is familiar and relevant to the authors themselves. When debugging applications using Chrome DevTools, authors generally want to see just their code, not that of the framework underneath or some dependency tucked away in a node modules folder. So you can see here that I'm searching for app component, and the first few entries in the list in this open dialog, they actually give me code that's related either to the framework or some of the dependencies that I have in my project, and app component is really the last one on the list there. And that's what I'm actually looking for. So to achieve this goal of retrieving what's relevant to the authors, the DevTools team has introduced an extension to source maps that's called Google Ignore List. And this extension is used to identify third-party sources such as framework code or bundler-generated code. And when a framework uses this extension, authors now automatically avoid code that they don't want to see or step through. And I'm explicitly saying when a framework, because this is available for all other frameworks to implement as well and to improve that debugging and profiling experience as well. In practice, Chrome DevTools can automatically hide code identified as third-party in stack traces, in the sources tree, and the quick open dialog, as well as improving the stepping and resuming behavior in the debugging. So you can see here, again, another example where there's a lot of, like I have a 404 error, there's a lot of call frames here. Only one of them is actually related to the code that I've authored. The other ones, for those of you that are familiar with Angular, have a lot to do with the core of the framework and Zone.js, which is something that it's not really our responsibility to debug. It's mostly the framework authors that should be looking into that. As a result of these improvements, you can see that we now have much more relevant stack traces that give us the context of the code that we've actually authored. The same applies to the call stacks that you see while you're debugging and stepping through your code. And another area related to debugging and profiling and, in general, error messages, the other feedback that we heard was that sometimes the error messages aren't very clear. So the team spent actually a significant amount of time just understanding what are some of the common errors that cause confusion. And we spent some time aggregating that by going to Google search results or going on Stack Overflow. We even saw people posting about this error on Quora. That's a good place to do it. And then we categorized these errors using error code. We wrote detailed error reference pages on Angular.io, and we also worked with folks at Fireship.io to record a set of videos for the visual learners out there. And we link to these error pages in the error stack trace as well. How many of you are familiar with the expression changed after checked? I can see probably 30% of the room raising their hands. It's one of the most common error messages, and rest assured, we're working to make that even more clear or maybe remove it in the future. Going back to the survey, another clear area of improvement is actually testing. We see it, it's the last down there. In Angular v12, we added support for 3 popular end-to-end testing frameworks, including Cypress, Nightwatch, and WebDriver.io. And for my friend Debbie, we also have support for Playwright in the form of a migration guide. Currently, new projects in Angular that run ng end-to-end will walk developers through choosing one of the integrated end-to-end frameworks. And these tools support custom builders and schematics, which automatically update your project's configuration so that it can integrate with your Angular applications. Furthermore, in Angular 14, based on community feedback that we collected via the request for comments process, we've decided to deprecate Protractor, while also working with the community to find a long-term solution for active projects that wish to continue using Protractor. We do understand that some of the teams might not be ready to migrate away of Protractor at the moment. In fact, that's also the case for some of the teams that we work with at Google as well. So we've partnered with the independent team at Hero Devs, who will be creating a fork of Protractor and maintaining it long-term. We also understand that end-to-end testing is only part of the testing story. So going into this year, one of our main priorities is investigating the challenges with unit testing in Angular and improving the developer experience there as well. So please send us your feedback. Don't forget about the Angular dev survey and add your input there. All right, shifting gears a bit, we also hear that you are excited about native tooling and faster build times for your dev and production environments. And currently, Angular uses Webpack as a bundler. We then use ESBuild for code optimizations like function inlining, and then Cursor for further code compression. And while this configuration is performant, with the recent evolution of tools like ESBuild, Vite, we think we can do better. So last year, we introduced experimental support for ESBuild-based system for ngBuild, which compiles to ESM pure output. And it also includes support for watch mode and your dev workflow. And over this coming months, we're looking to make bring ESBuild support in Angular to stable, and kind of get feature parity there with what you currently can do using Webpack. And just to give you an example, okay, I hear some people being very excited about that. I want to give you the numbers as well. So you can see here on the left-hand side, I'm running ng-build in a project using the currently stable build pipeline. And on the right-hand side, I've configured a new project to use ESBuild. And you can see that the first project takes about 7.1 seconds for the cold build, while the ESBuild-based project takes about 3.67 seconds. And this is consistent with our findings that with ESBuild, we have 57% faster cold builds, which is really exciting. You can enable this today in your projects by editing angular.json and replacing build Angular :browser with Angular browser -ESBuild. But remember, this feature is experimental at the moment, so please give it a try and share feedback with us on GitHub. The other main theme or strong theme that we talk about is reducing the learning curve for Angular, or like simplifying the developer experience for Angular. And one way to do that is by reducing the number of concepts that developers need to learn early in their journey. And that's why we've worked on making ng modules optional. As you can see in this Hello World application that you can see just here, in order to get started with the simplest application, developers need to write a component, they need to declare it in an ng module, and they need to bootstrap that application. This can be a lot of information for a new user that's just getting started, either with their web dev journey or just getting started with Angular. And one potential area of confusion that all of you that haven't used Angular maybe might already ask yourselves is like, what is the difference between ng module and JavaScript modules? And in fact, we ended up writing a guide that kind of walks you through those differences. And furthermore, the ng modules API surface can be quite complex, and it has multiple responsibilities. It includes compile time configuration through the declarations array, as well as runtime configuration for dependency injection through the providers. And it's also responsible for composability and grouping through the imports and exports arrays. We know that ng modules are a great way to organize your application and really separate the concerns of the different pieces of code that you're building or different pieces of application that you're building. And over time, many, many patterns have emerged, and we see different types of modules being used in production. And these are all great tools and great mental models to use for more complex applications. But we really wanted to explore what a simplified experience would actually look like. So that's where the Angular team spent quite a bit of time on making ng modules optional within the framework and introducing the standalone APIs. And we call them standalone components, directives, and pipes. Getting started with Angular using standalone components is as simple as writing your component and then bootstrapping your application. And you can see that this requires a lot less concepts or less concepts to have to learn in the beginning. And even from a code perspective, there's clearly a reduction in the surface area there. And one of the side effects of standalone is now that components are now the smallest unit of reuse, and you can directly lazy load your component. This simplifies a lot of the use cases related to the router as well. And rewriting some of the router APIs to add support for standalone, it actually enabled us to shave off 11% of the router bundle in cases in which you might not be using some of these APIs. And to be clear, the goal is not to remove ng modules, but rather to enable a getting started experience that doesn't require folks to learn ng modules until maybe later in their journey. And we made sure that standalone works really well with ng modules, ng module-based applications. and that you can easily import ng modules in standalone applications and the other way around. So interoperability between the two types of applications and the two types of components was actually one of the most important principles as we started designing these APIs. Apart from simplifying the learning experience, standalone also allows us to ship some features that we weren't able to do before. So one of them being the directive composition API, which enables you to compose behavior from one or more directives into a single directive. Previously, folks would either have to write TypeScript mixins to be able to do that, or they would have to write error-prone code that had, they had to duplicate code and use directives in multiple places. But with the directive composition API, basically, host directives tells Angular that whenever a menu with tooltip, as we see it in the code here, is created, then the CDK tooltip and the CDK menu directives will also be applied to that directive as well. If you want to learn more about the composition API, Jeremy has an excellent YouTube video on the Angular YouTube channel. And there's another one from Jessica on standalone components as well. Ultimately, our goal is to help put the user at the center while reducing the friction for building great experiences on the web. And Web Vitals are a great way to help quantify or put a number on the user experience for your website. And the metrics that make up core Web Vitals usually evolve over time. And the current set actually focuses on loading, so that's the largest contentful paint, interactivity, first input delay, and visual stability, the cumulative layout shift. And particularly in Angular, we have collaborated with the Chrome Aurora team to investigate and improve core Web Vitals for Angular projects at large. And one of our recent focuses has been improving largest contentful paint, so LCP. And one of the first things that we see is that 71% to 79% of pages that had an LCP element, that element was actually an image. So that gave us a lot of good focus to really further dig into how can we improve images so that all Angular applications have good defaults for good core Web Vitals. So we wanted to make it easy to adopt performance best practices for loading images. And particularly, we focus on intelligent lazy loading, on prioritization of critical images, optimized configuration for popular image tooling, and providing built-in errors and warnings as developers build applications. In your applications today, as of V15, you can use the new image directive by updating your image source to use ng source. And you can immediately see improvements to your core Web Vitals for your applications. The other bits are around setting up an image CDN so that you benefit from serving images in some of the more modern formats and reduce size there as well. Check out our developer guide for more info and feel free to use it today. Looking ahead, there's a couple explorations that are top of mind for the team. We're looking at how we can continue to improve our documentation. We've made significant progress this year by upgrading some of the guides related to dependency injection, for example, and we're working on the components guide. But we know that there's more that we can do related to our initial learning journey. We also want to make sure that we have excellent usability of the docs and that there's consistency of presentations of different types of topics that you might find on the Angular website. We're also improving server-side rendering. Some of the areas that we're focusing on are kind of implementing non-destructive hydration. We want to add standalone support in Angular Universal, which is our server-side rendering tool, ESM support, and we want to continue to improve the dev server experience. And finally, we're exploring reactivity and asking questions like, can we have per component or per view change detection? Can we have zoneless Angular? And can we have computed properties? But most importantly, we're exploring all of these topics with the priority of evolving Angular while also maintaining platform stability and bringing everyone along. And maintaining the properties of an opinionated framework that includes the knobs so that developers can use it in a way that exactly fits their needs. Thank you so much.
Hello, everyone. How's everyone doing? Give me some energy. It's second. So my friend really had a great talk on Angular, and now I'm going to talk about React. By the way, how many of you know both Angular and React? Oh, smart people. I'm definitely not that smart. So what I'm going to talk to you today is about the new features in React 18. So React 18 was launched in March 2022 with the major focus on performance benefits. Today, I will cover almost all the new features, including automatic batching, concurrency, which is one of the breaking change in this version. Then I will go over the new hooks introduced, including use ID, use transition, and use deferred value. Then I'll talk about suspense, what is suspense in general, and what are the changes in this version. So a bit about myself. My name is Aashima. I'm working as a front-end engineer in Amsterdam. I worked with Miro and Booking.com before. I also create some content on LinkedIn, so if you want to check out some short videos. And if you have any doubts after this talk, feel free to reach out on LinkedIn or Twitter. So talking about automatic batching. So we all know that whenever there is any state update, React does a re-render. And batching is when React group those multiple state updates in a single render for performance benefits. To understand this better, let's look at an example. Let's say we have two state variables. One is count, and the another one is active. There is an event listener increment count, which is attached on the button click. And what it does is that it updates both the two states. Now, ideally, since there are two state updates, so there should be two renders. But what React does is that it automatically batches these two state updates, so we only have one render. But what happens if I wrap it inside any asynchronous function like setTimeout, or inside .then callback or fetch? So in this case, React does not automatically batch it. So there will be two renders here instead of one. But now in React 18, everything is batched out of the box, irrespective of if you are calling the state updates inside any asynchronous function or not. However, sometimes you might want not to batch the state updates. So you can wrap that particular state inside flush sync method, and React will do an extra render for that particular state update. Next we talk about is the use ID hook. So the use ID hook was introduced to generate IDs which are consistent across both client and server. And this part is important, that all the IDs generated are consistent across both the client and server. Now, why do we need unique IDs? We need unique IDs for the accessibility. In order to support accessibility, we use ARIA attributes like ARIA live, ARIA described by, and we need to use IDs there. So let's say we have a component, which is a form component, and it has a password field. Now here, one way is that I use hard-coded IDs, like I'm using here a password hint. But the problem with this is that your component might render multiple times on a page. And in that case, the IDs will no longer be unique. So what's the another way? So what we can do is that we can use mat.random to generate a unique ID. And this works well on client. Yes, it's OK. We can generate it. But the problem comes with the server-side rendering. Because during hydration, when the mat.random will generate a random ID. So we'll have an ID mismatch during hydration. So that's why we had a hook, useID. We can call useID, and it gives us this unique ID, which can be used for the ARIA attributes as well as for the ID attribute. Now, let's say I have some more fields in the form, like first name, last name, and we also want to use unique IDs here. So what should we do? Like, call this useID 3 times? OK, but your form might be long, right? It can have 20 fields. So then calling it 20 times will not be very efficient. So what we do instead is that we'll call it once and use it as a prefix, like I'm using it here with ID, then first name, then ID, and then appending last name. So we call it once, and we can use it as a prefix. The IDs look something like this. So it's some binary format which represents what is the position of elements in the DOM tree. Next we talk about is concurrency. In order to explain concurrency in React, I'm going to give you a hypothesis. Let me take you to the back days of HTML. So let's say you have multiple script tags in your HTML, and which are specified in the same order, script A, B, C. Now, what is their order of execution? So the scripts are executed in the same order in which they are written. So first, A script will get executed, then B script will get executed, and finally, C script will get executed. Now, let's say my A script is very heavy, and it's taking a long time to execute. So now my B and C scripts are blocked because my A script is taking a long time. But in HTML, we can defer the script. So now the new order of execution becomes B, C, and then A. And this is exactly what concurrency in React is. Just that instead of script tags, you have some state updates. So before React 18, all the state updates used to happen in the order in which they were written. So first, Twitter will do the layoffs, then Meta will do the layoffs, and finally, Google will do the layoffs, which I had no idea when I was writing this slide. So all the state updates were synchronous. But now, React can pause, interrupt, and abandon a render. While this sounds like a jargon to you, let's say how we can use concurrency to improve performance of our application. So I have here a list of items, which I'm going to filter. So this list is really long, very long. Like 5,000 items, you're going to filter everything on the client with no offenses, just for the sake of this example. So the code for it's very simple. So we have 2 state variables. One is for the query, and the another one is for setting the filtered items. So now on input change, I call the function filter items, which will filter the items based on the user input. And it sets the 2 states, set query and set filter items. Now let's see what happens when I try to type here, try to filter. There's a bit of lag, but you cannot notice right now. Let me show. So I'm going to press back. I have pressed back. My hands are up. But if you notice, the search box and the items took a while to actually execute. So let me do it again. So I'm filtering. Sometimes you really want your computer to be slow. So my hands are up. OK, it took a while. So it's not a very good user experience because user is feeling lag as user is typing. So what I want here is that my user input should be instant. As the user type, the search box should give an instant feedback, but the list of items can still wait. It's OK to have that, a bit of lag in that. So here, the lag is because I'm setting so many, like 5,000 items on the UI. So this set filtered items is like my heavy script. It's taking a long time to get updated. So what's the solution? We want to defer it. How we can defer in React is using these two hooks, use transition and use deferred value. So we can import use transition, and use transition returns us two things. One is pending flag and start transition. Now you simply wrap this heavy update, which is set filtered items, inside start transition. Now let me show you how this behaves. So as I'm typing, it's instant. When I clear it, the input box is instantly cleared, but you can see the list of items is not updated. My input is clear, but the list of items is still showing the stale results. So it's taking a while, and now, yeah. So what we can further do is that make use of this pending flag to show the loader. So we'll do is pending, and if the transition is still in process, then we show the loading state. Otherwise, we show the list of items. And this is how it looks now. So I'm typing, and then as I click back, there's a loader, and then we show the list of items. So here you can see that we improve the performance, that instantly when user is typing, the user is getting an instant feedback. So it does not feel laggy, and the UI is not blocked. Now what I'm going to do here is that I'm going to take out this part, like the filtered items, this list inside another component. OK, sorry. So what you can also do is that you can sometimes it's better to show stale results. So what you can also do is set an opacity of the list to 50%. So now I've taken out that code, like this particular this UI list inside another component, which is my item list component. And let's suppose you don't have control over this part of the code because it's logged or it's coming from some third API, but you're not allowed to change this. You cannot wrap this state inside use transition. So what is the another solution? Because I still want to defer my heavy update. So here, what we can do that instead of looping over the items, I can use the hook use deferred value. And this value is lagging behind. So this is not the updated value. So as you type, this filtered item gets set, right? So as I'm typing, the value is changed. But this deferred items value is not set immediately. It's like a debounce. As I'm typing, the value is not getting updated for the deferred items. It will get updated later on, at the end, when all the updates have been complete. So this value is lagging behind, and I'm looping over the old value. So this update is not taking very long time. Now I want to show the loading. So what I can do here is I can check that if deferred items is not equal to the items, then I can show the loader. And this will work exactly the same way as use transition. Now, when to use what? So it's advised by the React team to use deferred value when you don't have control over the state. So when you cannot use transition to wrap your state, so you can use deferred value. Otherwise, it's preferred to use transition. But there is also a catch. Both the use transition and use deferred value, they are doing an extra render. So if you use it too much, it's not going to make things better for you, but instead worse, because your application will get slow because of extra renders. So they are great tools, but use it wisely in your application. So I'm going to take a pause to digest whatever I said. By the way, are you guys familiar with the beta docs? This is like really, really good. So like it's really well explained. So you can read more about use transition. There are a bunch of examples you can go through. And same you can do for the use deferred value as well. So last part is I'm going to talk about suspense. How many of you are already using suspense? OK, only some people are working with Next.js. OK, suspense, in general, it lets you specify the loading state of the part of component tree when it's not ready to be displayed yet. So there are like 2 use cases for suspense. So one, we use suspense for displaying the fallback for lazy loaded component. Like if I have a component profile, which I'm lazy loading, so I can wrap it inside suspense and show the loading state by specifying the fallback inside the suspense. Another big use case of suspense for which suspense got really popular was the data fetching. So let's say there is another component, posts, which fetches a bunch of posts and returns those bunch of posts. Now, I also want to display the posts. So what I can do is that I can also wrap it inside suspense. And now, the profile and post will get loaded. So the suspense will show fallback if both of these components are not completely loaded. What suspense is really useful in is that when you have multiple loading states on the screen, when you have multiple loaders. So in this case, let's say I want to show profile even if the posts are not completely loaded, right? I don't want to block the other parts from getting displayed. And these things can be very easily controlled with suspense, that you can wrap this post inside suspense fallback. So this works like a try-catch. And one thing I want to mention here is that this fetch post part. So this needs to be compatible with this suspense API. If you're using Next.js or if you're using Relay, then by default it's supported. With React query, it's not yet supported. So you might have to write an additional function which is compatible with suspense. What you can do to catch errors is that wrap everything inside an error boundary and show the error in case anything fails. So this is how suspense was used to work before React 18. So it was mainly used for code splitting and was only supported in client. But now, suspense is also supported with server-side rendering. So let's say, let me first briefly explain the server-side rendering. So in server-side rendering, when user requests a website, server sends an HTML to the client, which is instantly shown to the user, so that the browser does not have to wait to download the JavaScript. So now, after the page is sent from the server, there's also another process of hydration, which is that server will try to match the file which was generated by the client and which was sent from the server. Now, let's say we want to server-side render this particular page. So we have a navbar, we have a profile, and this post is a data fetching component. So it's loading like a bunch of posts. But like if my post component is slow, right? So my server needs to download the post before sending it to the client. And if my post component is slow, it's going to take a while to send the page to the client. And this kills the whole point of server-side rendering, right? Server-side rendering is meant to improve the FCP. But with suspense, what we can do is that we can use suspense to show a loading state when the posts are not ready. So now we are going to ship this HTML to the client, even though the posts have not been downloaded. So now the next part I mentioned is hydration, right? So the hydration needs to start once the page has been sent and the client has downloaded. So what about the hydration in this case? So what suspense does is that it allows selective hydration. So first, what I received from server was this loading. And the hydration will happen for the navbar, for the profile, and for this loading. And when posts are ready, they are sent from the server again. And there will be a separate hydration for just for the post that was sent from the server. So this was what suspense is. So this was mainly about streaming HTML and selective hydration. Thank you for coming to hear my talk. And you can check out the slides on this Netlify app and check out the code examples on the GitHub. Thank you.
Well.
There we go. Hello. Thank you all so much for having me. I'm so excited. Thank you, Elian, for that awesome. I feel like I have a hype man, which is very exciting. I've never had that before. This has actually never happened to me before, so I'm a little caught off guard. Before getting ready for a talk, I'll kind of go to the program, I'll check out what's going on, get a sense of when my time is, who I'm going up against. And so I did that today, or I did that a couple days ago as I was getting ready. And I'm like, okay, 5 o'clock, it's like end of the day, kind of chaotic afternoon energy. Quick, that's another framework. They're going to come after me. That's great. I can kind of bounce ideas off of that. That'll be fun. And then I look at the program, and who's this Elian guy giving the exact same talk that I was planning to give? I've never seen that before. 2 talks, exact same topic, back to back. I didn't know what to do. So I reached out to Jos, who's one of the organizers, who, by the way, the organizers have been phenomenal. Can we give it up for them? This is an unreal, this is an unreal conference. So I don't think Jos will mind if I then kind of give him a hard time now, because I reached out to him, and I said, hey, this must be an accident, 2 talks, back to back, let me know. I'm happy to change with anyone. We'll kind of split it up, like I can go another day. And Jos is like, no, sorry, it's a packed conference, can't do it. Oh, no, it's a 3-day conference. I'm sure someone on Thursday. Today's Wednesday, tomorrow's Thursday. I can switch with someone on Thursday. I was like, no, sorry, Thursday's Vue day. Like, okay, no, well, that's fine. Like, Astro and Vue, that's actually a really cool story. We have a really great, relationship with them. We can tell that story. He's like, no, it's not going to work. It's like, okay, all right, what about Friday? Friday, there must be some room. That's Vite day. Okay, well, we actually have a really great Vite story. We work with them a lot. We're actually powered by Vite internally. One of our maintainers is a Vite maintainer, so there's got to be some way to kind of tell the story there. No can do. So you guys figure it out. Good luck, click. That was about what the answer was. I'm sure Jos would tell that story a little differently. But the point is, Elian and I had to figure out, all right, what are we going to do? Same talk, 2 people. What's the deal? So Elian's given that talk before. He had it knocked down. He's doing his thing. That's awesome. And so that kind of leaves me a little free to talk about whatever I want here. And Creator of Astro, that's not a title. I don't know who wrote that. That's not a title. That's a description of me. That's not a title. So I am truly out to sea here. I have nothing. I'm just a blank slate. As Elian kind of talked to, but for anyone who's watching online or didn't catch that, Astro, if you're not aware, is a framework for building content-focused websites. It's really, really fast, faster than anything from Next to Nuxt. We get to make a ton of trade-offs that they can't because we're really focused on that content story. And so it's this really cool architecture called Islands Architecture. You should definitely check it out. A couple of highlights. We were #1 in developer interest and satisfaction in the State of JS survey. Very exciting. We were the #1 developer tool on the StackShare's top developer tool list of 2022. We somehow beat out ChatGPT, which I don't think is right, but my mom was very proud, so I guess I'll take it. Even she knew what that meant. And we just had an Astro 2.0 release, which had a ton of cool features around content collections, working with Markdown and type safety, hybrid rendering and SSR. So it's been a really, really fun year for the project, seeing it grow and mature. Yeah, thank you. Thank you. Yeah. But I don't have to talk about any of that. I have a totally blank slate. I'm just going to go off, do whatever I want. So I was kind of figuring out what I should talk about, and I realized as I was working on my talk, I had weeks of built-up hot takes. All right, weeks of Twitter drama that I have not had the opportunity to comment on. Y'all have been crazy. I don't know if there's something in the water, but Twitter's been a mess and I have not commented on any of it. So strap in, we got some takes, all right? Git merge versus Git rebase. I can't see any of you, so I'm gonna need like a show of noise. Who's team Git merge? All right, Git rebase, team Git rebase. Wow, all right. Team, it's a nuanced topic that you can't boil down into a yes or no. All right, these are Twitter takes, you're wrong. There's a right answer and it's Git rebase. Git merge makes me feel dumb. I don't know how to use it. If you're telling me that you're gonna get 100 commits over here and 100 commits over there and somehow zipper them together, I don't believe you. I can't do it and I'm blaming the tool. It's not my fault, it's Git's fault. Git rebase is the right answer. All right. Explicit types and inferred types. This was a huge like TypeScript Twitter drama of the last couple of days. Who's explicit return types? Being really explicit, typing them. All right, I kind of subdued. The TypeScript community is a little quiet. Inferring your types in TypeScript. Okay, you're wrong. It's explicit types. It's the only right answer. I don't care. Every thought leader came out saying inferring your types is the only correct thing. No, it's explicit types. I will argue this. It's a hill I'll die on. Every time I do a return in TypeScript that doesn't match the return type, I find out about it somewhere else. I do that all the time. Again, I don't trust my own code. So for that reason, explicit types catches this bug for me. All the contrived examples where you can like lie to TypeScript, I don't care. That's the thing I care about. It's Twitter, so there's no nuance. I'm right, you're wrong. That's Twitter. All right. We have to cover it. We have to cover it. I'm not even going to ask. I'm just going to say, if you like Tailwind, use Tailwind. If you don't like it, don't use it. You don't need to, that's it. Just let people use what they want. Just let them be happy. Obviously, it's Twitter, so you're not allowed to do that, but that's my hot take. If you like it, that's great. I think I would add one requirement, which is if you're going to make fun of Tailwind, and there's a lot to make fun of, don't get me wrong, you also have to include information about what your favorite thing is. Because this is, I think, what's wrong with the discussion, is that there is no such thing as a good styling system. They're all in some way bad. Like you're trying to take the infinite possible visual art of the world and distill it down across any viewport, any device size, anything you can create online, and you're trying to distill that down into like code is a like inherently flawed endeavor. And Tailwind, whatever, like BEM, your like CSS modules, they're all bad. I think they're all bad, and we're all just trying to find out what's the best for us. So there you go. That's my hot take. They're all bad. Use whatever you want. My last hot take will take a little bit more time, so we got some time for this last one. If I did write my own talk title, which again, I wasn't able to, the talk's not called Creator of Astro. If I did write my own talk title, it would have been this, which is a really interesting trend, and I'm seeing more and more about it, and it's something I really care about. So this is something I want to talk about. I want to talk through what does type safety mean? Am I talking about TypeScript? Am I talking about something else? This is a trend that I think is going to have a huge impact over the next couple of years. And I think there's things that you can do today in your own work to start to take advantage of what this means for a better developer experience, for being more productive, for catching bugs easier. This idea of type safety is very much somewhere between on its way and here. And so I want to talk about what this means for development. This title is a riff on this old saying, which is JavaScript is eating the world. If you tweeted this in 2013, you were super cool. Like this is like the most punk rock thing you could be talking about in 2013. Because we take for granted that JavaScript is kind of everywhere now, but at the time, it was like kind of controversial to say that you could like run JavaScript on the server. So funny enough, at my old job, one of my very first jobs, we were on the team that was trying to bring Node to a like pretty enterprise, kind of growing software company. Just by total coincidence, by the way, my manager is somewhere in the audience. So my manager from 10 years ago, hi, great to see you again. It's been a while. It was such a controversial idea to bring Node into this enterprise that they almost literally forced us all to learn Scala as front-end developers. Because JavaScript, like the idea of shipping Node in production was that scary. They'd rather retrain 20 to 30 developers who'd only ever worked in HTML, JavaScript, and CSS, Scala. That was how scared people were of Node and JavaScript. We luckily didn't have to do that, but I think it really speaks to just how kind of we take this for granted that JavaScript is a serious language now. We're at like this beautiful venue talking about JavaScript. Like 10 years ago, it would have been like a hut by the river, and like we would have all brought our own snacks. Like this is very different from when I was getting started in web development. And I know this isn't one-to-one, like NPM is kind of its own thing, but I think it just speaks to the idea that NPM, JavaScript, Node, it's all still growing. And if anything, it's kind of accelerating. All right, so JavaScript seeing the world, that was kind of the hot take of 2013. TypeScript seeing the world, that's kind of like the phase 2 of this. This one is one of those things that's, I think, secretly kind of been going on, and all of a sudden is becoming very obvious. In that same State of JS survey, developers are actually, the majority of developers are using TypeScript. They're either entirely in TypeScript or like almost entirely in TypeScript. This is a survey, how do you divide your time between JavaScript and TypeScript? Yeah, this is kind of a startling answer. I don't know, this startled me at least. I knew it was popular, I didn't realize it was this popular. Only 1 in 10 developers essentially is working only in JavaScript, not touching any TypeScript. The rest, somewhere on the spectrum of using TypeScript. This is something that's, I think, really interesting because a lot of the kind of popular tools of today weren't designed for this reality. Or even worse, like weren't designed for the future where this accelerates. This is actually one of the things about Astro that I find really interesting because we're a part of this kind of newer breed of frameworks designed for this future. It's one of the actually interesting things. We kind of get to like see where the puck is going and try and skate there a bit, which is that Astro is 100% TypeScript. You can't turn TypeScript off in Astro. You might have seen that question in Elian's demo where we walk you through kind of, do you want to write TypeScript? You still have the option not to write TypeScript, but like we're going to be running TypeScript anyway. It's kind of the trick of TypeScript is that it's a superset of JavaScript. So if you want to, you can keep writing JavaScript, but it's still TypeScript. Like we're still doing the work behind the scenes to use TypeScript, even if you don't want to. I think that's really interesting because I think it unlocks, like, I don't know, I've tried to bring TypeScript into other projects, other kind of components, and it's one of the nice things about Astro is we kind of like, it's if you look back at that data, it's becoming more of the norm and less of the like, oh, maybe if you go through these extra 10 steps. So that's something I'm really excited about. Again, you don't have to use it, but it's there for the people who want it without a lot of extra steps. All right, that's the context. Here's the hot take. So type safety is in the world. How is that different from TypeScript? First, I want to just kind of quickly show, if you're not familiar, JavaScript, and then TypeScript. So TypeScript is this idea of adding a type to something so that you now get kind of information about. So if you kind of look at foo, you're going to see that it is a user with a name. This is where TypeScript actually kind of falls apart here. So you can see here that we're making a fetch call, and we're telling TypeScript that its type that we're going to get back is user, it has a name. So we're saying it has a name. That's all you need to know. That's what we tell TypeScript, and TypeScript's happy. The problem is that this fetch call is going over a network. So all of a sudden, we're actually leaving our code base, and a lot of things can happen. Like TypeScript kind of just throws up its hand and says, you tell me what this is. And the problem there is that we don't really know that we're getting this thing back, right? We could get back a 404, we could get back a totally different object. Name could have been replaced by first name and last name. The network could be down, the client could be down. Anything could fail along that whole thing. Like, you've lost a lot of the type safety that comes with TypeScript. The way I'd say it is that TypeScript is only as powerful as the types that you give it and the types that it can see. But the second you're kind of leaving the world that you've created of TypeScript, you're kind of on your own. And the problem, the only reason this is really a problem over what you have today is TypeScript makes you feel like you have full type safety. But in reality, you're kind of just trusting that your types, which you're manually maintaining, no guarantees, you're trusting that these are actually accurate, and that's not always the case. So anytime you go across a boundary, anytime you leave your code base, that could also be libraries and frameworks. Another example, which I actually luckily was just chatting with Chance from the Remix team. This is not an accurate reflection of Remix today. This actually illustrates my point is they've moved from this to this kind of more inferred world of automating this. So it's actually kind of the perfect point. I don't have to drag Remix. They've kind of fixed this. But if you look at this right now, this is a lot of kind of TypeScript, but I wouldn't really argue that it's a lot of type safety, or at least there's a lot of room for human error. It's a lot of boilerplate, and it's still on you to maintain all this code yourself. So for example, you've manually defined the loader data that Remix is going to give you with your return type, your getUser, your getEnv. You've got the loader function, which you've now also typed. You've given it this kind of loader function, const loader type. And then you've had to pass that data from the first one all the way down here into the JSON just to properly type it. So again, this is no longer the way it works now, but this is a good illustration of like, this is where they started with TypeScript, which is that you have to like go through these extra steps. That again is really dependent on you telling TypeScript the truth. And anytime a human is involved in that story, there's a lot of opportunity for lying, incorrectness, maintenance, kind of things get out of date. legacy code can really kind of mess up your day. So this is when I talk about type safety. I'm not saying TypeScript, because I think TypeScript's already here. I think it's this idea of automating more type safety, guaranteeing more type safety, and doing it in a way that's really, really invisible to the end user. And finally, can we kind of cross that final end-to-end step of that relationship? Can we actually give you type safety reaching out of the TypeScript code base, not necessarily just inside the island you've created? This is one of my favorite features that we've ever launched. We launched it in the 2.0 release, and it was type safety for Markdown. So we really wanted to kind of try this out. It was the idea of, if anyone's ever managed a project with like 20 plus Markdown files, you know how tough it can be. Like all that front matter can just be really, really tough to maintain, right? This property is out of date. This one, you copy paste to create a new file often, so you're kind of bringing a lot of garbage basically at the end of the day. It's really hard to maintain large Markdown collections. And so what we wanted to do was actually bring this idea of type safety into Astro for working with Markdown, but also guarantee it, give actual end-to-end guarantees about type safety. So you're not lying to TypeScript, you're not having to come up with a representation of the truth, it's actually literally just the truth. The two ways we did that, one is the schema, which is actually going to verify the content. So let's say you have a bunch of blog posts, they have a title, description, all this cool stuff. We will actually go and run this across your whole content directory. So all that Markdown is actually going to get verified that it matches. So anything that's out of date is actually going to be caught. Versus if you've ever had that bug where like somewhere in the template you're referencing a property that's not defined, you get a undefined is not resolved, and you end up tracing it down for an hour into a different part of the code base. This is actually going to give you this really nice error at the actual post saying, hey, here's the problem, the title's missing, go at it, we're good to go. So you get this really nice content flow for verifying your Markdown, verifying your typed front matter. And then the other thing you get then is also on the access side, you actually get type-safe access to your data. So let's see, hopefully this video works. Yeah, so working with a post that you've gotten back from this Markdown now, you're actually getting that same front matter, but instead of like an any object, instead of not knowing what your front matter is actually going to be, you're actually getting the raw, like guaranteed type of that data. So you can see all your properties, you can kind of auto-complete them, you can verify them, and you actually get the guarantee that it's there, versus you telling us, telling Astro it's there, but not really having a way to verify. So this is that end-to-end story that's really, really powerful. This is really, really new to Astro. I think we're the first framework to ever really double down on Markdown this much, and I'm really excited with this result because I don't think I've seen this anywhere else. I will shout out, Prisma has been doing this for way longer, so we don't get the credit for TypeScript. That's not what I'm saying. Prisma has been doing this with databases for forever. The idea of you can actually create a schema that defines your database, and then we're going to auto-generate a database client for you automatically. That's really powerful. They've been doing this for way longer than it's been cool. So shout out to them. The other kind of credit where credit's due is Zod. So Zod is this kind of magic engine that's really, I think, responsible for a lot of this innovation over the last year. You've actually already seen Zod in this presentation. If you go back to this example, here is Zod actually powering the schema. So that's z.object, z.string, z.boolean. That's Zod. So Zod is actually what's responsible for the guarantee. It's giving us the guarantee of a schema that will bring runtime checks to TypeScript, but also the types that get automatically generated from it. That's what kind of fills the circle there. So we're relying on that a ton. Again, Zod gets all the credit here. We've just hooked it up in an interesting way. If you want to take this idea even further, there's a TRPC. So if you haven't tried this out yet, it's really cool. It's for building APIs using type safety across the boundaries. So again, you're getting a guarantee of the type going in and the type going out of any API query. I just grabbed this video from the homepage. It's a lot, but the important part is down at the bottom. You're going to see it's going to play, and it's going to show you what happens when you actually refactor this. When you rename a property, you immediately get type errors across your project, both on the server. You can see one down there. We're going to fix that. And then on the client, go and fix that. That's exactly what TypeScript is terrible at, is that you actually make a change on the server and then no one bothers to update the return type on the front end. You're going to have a bad time. So this automated, guaranteed, verified, end-to-end type safety is, I think, what really is coming. It's undeniable how powerful this is. People can choose not to use it. That's great. Again, use what you like. But I think this is something that is only now being seen as viable because it's so new. And I think if you look at the progress over the last year, this kind of stuff is happening more and more. It's really coming. I will say, it doesn't mean that you have to go greenfield, start a new project. I hate when the thing is all right, you have to throw everything out. we actually use this on another project, which is the idea of bringing open AI types. So if you've ever worked with a REST database, or sorry, REST API, OpenAI is a way to actually kind of create a schema. You can generate TypeScript tapes. It's pretty close to actually this experience. You actually get the guaranteed from the schema across both the backend and the TypeScript types on the front end. I will also call it Next.js. They're doing some really wild stuff with TypeScript. So I don't know if anyone saw this video. I'm actually just going to let it play while I drink some water. Hopefully this buys me some time. So you're going to notice here, no one is actually writing TypeScript here. This is all JavaScript so far. But this is actually getting you full docs, full information, full guarantees. If you do something that isn't actually documented and correct, it's going to yell at you. You don't have to go to the doc site to find out why. This is really, really powerful because this is actually bringing all this information into your editor without you actually having to write any TypeScript yourself. This is all just essentially JavaScript. And so this is why I think this is so powerful, why it's not just like, oh, this will be a thing that like TypeScript people enjoy, is that you actually don't have to write TypeScript to use this. Again, Astro lets you write JavaScript, but we're running TypeScript anyway. That's one thing, but VS Code has really gotten powerful. VS Code is really trying to push TypeScript, which means pushing TypeScript information into JavaScript apps. So even if you're not writing TypeScript yourself, you get a lot of this cool information. The future is type safe. It's super powerful. It helps you catch errors. It helps you be more productive. It helps improve your DX. Again, if we think of TypeScript as the way to express types, like it is the language of types. But I think we're only now just starting to see the actual power that comes from having that language at your disposal. What can you actually do? How can we push that to the absolute limit? I think that's the difference between, if we can call these phases, the phase 2 and the phase 3. We had JavaScript, we have TypeScript, and now I think this is going to be the next like kind of way that we improve. The next way that we focus on libraries, improving the sorts of things in our frameworks. It's kind of the interesting thing about this is that this isn't actually necessarily something that any one developer needs to, again, throw out their code and learn. This is actually more of a kind of responsibility of the tools and the frameworks and the libraries to update. So the nice thing about this is this can actually happen, pretty quickly, because it's not about getting a lot of people, it's about getting a very small group of libraries out, and also B, it kind of happens much more organically. Someone can try something out, if people like it, they use it. If people don't like it, it kind of goes into the history books. And from that, we get more and more innovation across this new way of just like thinking of type safety as automated, invisible, end-to-end, guaranteed, verified, all that good stuff. So this has been hot Twitter takes plus one very deep dive. But if you liked any of this, check out these projects. They're all doing really interesting stuff with type safety, TypeScript, and just all deserve really cool shout outs. Astro 2.0, go check it out at the website astro.build. We're astro.build on Twitter. And again, thank you to Elian for giving that awesome Astro kind of overview so I didn't have to. Thank you very much.